I know many of you clicked on this video because Databricks is getting popular. In this complete micro course, we are going to first learn the foundations of Databricks, and then we will build end-to-end data engineering project in e-commerce domain. We will do our data processing through bronze, silver, and gold layers, and eventually build business insight dashboard. Throughout this course, we will be using Databricks free edition. This free edition enables students and practitioners to learn professional data and AI tools for free. For people who don't know what Databricks is, it is a leading AI and data platform for enterprises. The reason for its popularity is its ability to simplify their architecture and speed things up at the same time. It has helped many companies like Mercedes-Benz to speed up their data-informed decision-making process by enhancing their business intelligence, and at the same time improve their query performance and run ML models on sensor data. We will learn more about distributed computing, Spark, and Databricks in our foundation section. Alright, let's jump into our project problem statement straight away, and we are going to use some interesting storytelling for this. A2Z is a rapidly growing e-commerce company headquartered in the United States. As their business expands, both the volume and velocity of their data have exploded. They currently rely on Python-based ETL pipelines for their analytical workflows. But these pipelines have become difficult to scale, causing performance bottlenecks and delays in dashboards. The company's head of data engineering, Tony Sharma, was called in to fix the issue. He quickly realized this wasn't just a coding problem, it was a scalability crisis. Meanwhile, Bruce Hariali, the chief operating officer, had been hearing complaints from business teams. Reports were delayed, dashboards froze, marketing couldn't see yesterday's data on time. Tony met Bruce in boardroom. They agreed the system had reached its limit. Python scripts were running out of breath. They needed something built for large-scale data processing. That's when Tony proposed Databricks, a managed platform that combines Apache Spark's distributed power with the flexibility of the cloud. Bruce agreed, but instead of a full migration, he wanted a pilot project, a small measurable test. Tony assigned the pilot to Peter Pandey, a curious data engineer known for tinkering with every new AI and analytics tool in the market. For Peter, this was more than just a project. It was a chance to learn modern data stack and replace old systems. He started building a pipeline on Databricks to test scalability and performance. So in this project, you will be joining Tony, Bruce, and Peter as they explore how Databricks can solve A to Z's scaling challenges and learn how cloud data engineering drives real business value.
Peter, you saw the email from Bruce? We got to explore Databricks now and see if it will really fit our needs.
Yes, I saw that email. I think I'll be able to do it.
Okay, but how? Do you know Databricks already? Have you worked with it?
No, not really. But Tony, nowadays things are easy to learn. You can go to YouTube and find some crash course.
I hope so, but let me clarify the requirement to you. Okay, I'm reading from the email. So you have to confirm 3 things as a part of your exploration, right? The first one is quite obvious. Of course, it should work better than our current ETL process. That is given. And the second thing is the tool should be easy to adopt, right? I don't want to spend too much time in training the entire team. It's not going to work, and it should be easy to adopt. And number 3 is it should fit our roadmap. So our roadmap, right? We are looking for 3 things in our roadmap. One thing is scalable. We should be able to accommodate any scale of data hypothetically. Number 2 is it should be agile. So what I mean by agile is we should be able to upgrade or downgrade infrastructure at any point without worrying about the cost, right? So you got that. And number 3 is I'm looking for a simplified platform, like a unified platform where, just imagine like our data engineers, data analysts, and the AI engineers all working together in one place, and it should essentially simplify our data workflow altogether. So that's the most important thing. So does it sound absolutely clear to you?
Yes, it's very clear. I'm excited to start work on this.
Great.
Now that you're clear about problem statement, from this point on, you have 2 possible learning paths. The first one is you continue from here, learn Databricks foundations, and then do the project. This is a linear learning path most suitable for those who don't know much about data engineering. The second one is a non-linear learning path where you go to project straight away, start building it, and when you want to refer to any foundations, you come back. This works best for the people who wants to get into the action straight away. Timestamps are provided in video description. I wish you all the best. Let's go ahead and create an account in Databricks. All you have to do is click a link down below in the video description and you will come here. This is Databricks free edition. They have created this free edition so that learning community can benefit, and we truly appreciate that effort. Setting it up is very easy. I'm going to use my Google account. You can use your email ID as well. So click on continue with Google and I will select my Google account, say continue. And here for personal use, get free edition, click on continue and start the puzzle. Okay, so I think this is the right answer. Hit submit. After a few seconds, my account is ready. Let's explore this UI quickly. Here you can upload your data. You can browse public data sets. So you can go to marketplace and look at all the data products and data sets. You can also go to catalog where you will see your tables, etc. So they have these three layers where at the outside you have something called a catalog. So this is a catalog. Under that, what you have is schema. So you have this default schema. And right now there is no data. So let me quickly upload the data. So you can go to home page, click on upload data button, or you can go to data ingestion here and create or modify table. Okay, click on that. And I'm going to provide you this movies.csv file. So which you'll be able to download using a link in the video description below. And this is a simple movies database where you have movie name, industry, release year, IMDb rating, and all of that information. So let's drag and drop this file here. And it is going to create movies table in workspace catalog. See, workspace is a catalog, schema is default. And here you will see a quick preview of data. All right. So see, I have my title and here it shows the data type. So this is string, this is string. Release year should be number, correct. IMDb rating, it is saying string, but we will change it to number, okay, because it's a double number. So let's change it to double. And if you just decrease your font size, you'll be able to see all the columns in one single view. Things are looking good. Click on create table. Now, when you hit a refresh button here, you will see this movies table. See? So here you have workspace catalog, default schema, and movies is your table. If you go to sample data, it will show you the sample data from your table. Details will show you the metadata of this table. So this is a managed table. We'll talk about managed versus external table later on. You have different level of permissions, policies, history, lineage, and so on. I clicked on SQL editor option and I will quickly run some queries. So let's say select star from workspace.default.movies. I want to view 5 records. And before you run this, you have to connect it to a compute. So I'm going to connect it with a serverless compute. So let me talk about that compute. So here I will go compute, right click, open it in a new tab. Now in a free edition, what you get is a serverless compute. See, this option is disabled. If you have enterprise account, you can create a compute where you can specify your cluster basically, okay, how many nodes you are going to have in your cluster, etc. But we are going to use this serverless compute throughout this course. So let's go to SQL editor and run the query and see, you see all your results here. Now serverless compute is short of like AWS Lambda. So see, behind the scene, they have servers, but all those details are hidden from you. So this way you can just focus on your business logic. You don't have to worry about managing your computers on cloud. Then there is this Genie option. So if you click on it, click on new, and you can click on your movies and you can create this Genie space, and you can ask questions like show me top 5 movies by IMDb rating. And this is an AI assistant, AI chatbot, where it will take a command in natural language and it is internally converting it to a SQL query, and see, it is showing you the results. So this is very beneficial. So even if you don't know coding, etc., you can just give these commands in a natural language and it will show you the results. We also have this option for data ingestion, where you can connect with different connectors, Salesforce, SQL Server. They have so many different connectors. If you click on see all, you will see this entire list. So you can connect to all these connectors, bring your data into Databricks and work on data engineering, AI, etc. And for AI, they have all these different options. Okay, so there is playground, experiments, there is model serving, and so on. Jobs and pipeline is something where you can create your ETL jobs or ingestion pipelines. And if you look at workspace here, you will be able to create a new notebook. So we are going to use all these options. I'm just giving you a quick overview of the UI here. Now we will look at Dataframe Basics. For this, I will go to my workspace and create a new notebook. Now, if you have studied Pandas has data frame. Similarly, Spark has a data frame, and we are using Python here. So the module or the library that we are using is PySpark. Okay, Spark is supported in Python, Scala, Java, different languages, but we are going to be mainly using Python. Now here you will find this object called Spark, and if you control enter and run it, it will show you this thing. Okay, so Databricks environment gives you this variable, this object, which is a Spark session object. If you are not running in Databricks, then you have to do something like this. See, you will usually write this kind of code where you will say, okay, import PySpark SQL Spark session and create this. But in Databricks environment, you get this object by default. Now let's create a data frame by calling this function spark.table. Okay, and here you can specify workspace.default.movies, and the return value will be our data frame. Now let's just execute this code. See, now it is showing you this data frame, and make sure you are connected to your compute. So here it will be serverless compute. You can also run df.show function, where let's say I want to display only 5 rows. Now this is not very well formatted. Display will give you a proper formatted table, but sometimes people use this show method because it is very fast. You can run df.print schema count, right? All of this useful methods. So let me run this one by one. So print schema will give you the schema of your table. So title is a string data type, IMDb rating is a double data type, and so on. You can then say df count and also print df.columns. Okay, so let me just print the count first. So number of rows I have is 37. Now you can verify it in your SQL editor. You can say select count star from your table. So let's do select count star from this table. And if you run it, here also you are saying 37 rows. Then you can do something like df.columns, which will give you the list of columns. Okay, it's a plain Python list with all the columns. Then you can run another useful function, df.describe. This is similar to if you use again pandas, it has this describe function. So let me use this display method so that you can see the nicely formatted output. See, here it is showing you the count. Okay, release year count. Okay, per column statistics. So what is min max? So for IMDb rating, my minimum rating is 1.9, maximum rating is 9.3, and my average rating in my movies table is 7.8. We have another similar function similar to this df.describe. It is called summary, and when you print it, it will show you similar columns, but it will show you additional data such as all these percentiles. Now, how do you do column filtering? Let's say I want to select only 3 columns in my data. So first, just like Jupyter Notebook, you can add markdown cells here. So I will just say column filtering. You can give it headers, etc. And here you can say df.select, and you can give a list of columns that you want to select. Let's say these are the columns, and I can return this into another data frame called df trimmed. See here, these data frames will be unmutable, which means you can't modify them. So I'm selecting 3 columns and returning it to a new data frame. Now in this new data frame, once again, you can say show 3. They have this another parameter called truncate, which is by default false. So let me just execute it and show it to you. So see here, I'm seeing only 3 columns. Okay. And when you set truncate equal to false, it will show you this entire text. If my truncate is true, this text will be trimmed, see, so that you can see the columns in a compact manner. Now let's do row filtering. So I clicked on text, and here I am adding a code for row filtering. And let's say I want to see movies between year 2000 and 2010. Okay. Now I can write queries, but I noticed this option of using generate with AI. So I'm curious in trying that. Okay. So let's do Control-I and then type in your criteria. Show me all the movies released between 2000 to 2010. Hit enter, and the AI assistant will write query for you. See, this query looks good. So you will say accept. And here, as you can see, you will use this method df.filter, where you will give your criteria. Okay, release years should be greater than equal to 2000 and less than equal to 2010. I will call this df filtered. Okay, so let's call this df filter, control enter, and see, now you're seeing all the movies between 2000 and 2010. Now the same thing, you can do it using other code as well, where you are importing this call function from pyspark.sql.function, and you can just say column release year greater than 2000 less than equal to 2010. Okay, so it will do exactly same thing. It's just there are 2 different ways of doing it. There is third way, by the way. So you can say df.filter, and you can say my column release year dot between, see, 2000 to 2010, and that you can store it in filter, and you can say display df filter. Okay, so again, this is the third way of doing the same thing. And how do you print all the movies which are released by Marvel? Okay, I love Marvel movies and I want to see all the Marvel movies. Same syntax. Okay, here in column you will use studio, and you will say Marvel Studio, and here are all your Marvel movies. Now I want to know how many distinct movie industries are there. See, here I am seeing Hollywood, but what other movie industries are there? Well, for this you will say df.select. You will select the column. Okay, industry is a column, and then you will say distinct, and this you can assign it to a variable called unique industries, and then display. Display function is used to display a data frame in a nice tabular format. Okay, so I have only 2 industries, Bollywood and Hollywood. Similarly, you can select unique languages, right? See, here if you look at this table, there is this language column. So it will show you languages for different movies. So I want to know, see here, it is saying that my movie dataset has movies in Hindi, English, Bengali, Kannada, and Telugu. Now see, my table has the budget and revenue column. Naturally, when I'm doing data analytics, I'm interested in knowing the profitability of each of these movies. And profit is nothing but budget, which means this is the amount of money that was spent in making a movie. Okay, and revenue is the revenue that it generated. So if you do revenue minus budget, you will get profit. So here you can create new column by saying df.with column, and this column will be profit, and it is nothing but column revenue minus column budget. Okay, and I will assign this back to the same data frame. In the same data frame, essentially I am adding that extra column. So control enter, and here you will see this new column. See profit. So see, for this first movie, revenue was this much, I think 100,000 and 70,000. So profit is 30,000. With column is a function that you will use a lot. In Pandas, if you want to create a new column, you will say df, then that column. And if you are creating it using existing column, you will say df existing column dot apply. Here the syntax is little different, but it's easy to remember, right? You just say df dot with column, you specify your new column name, and here you specify your expression. Now, when I look at revenue column, I feel like I want to rename it to total revenue. So it shows it's a total revenue generated by that particular movie. And you can do that easily by saying df dot with column rename. See, so here I will just change revenue to total revenue, assign it back, and then say df dot print schema, and see, here it is total revenue. In the last lecture, we did some basic analysis on the movies dataset. And by the way, movies dataset you might have seen in our SQL course if you have taken SQL course from Code Basics. Now we are going to give some name to this particular notebook. So we will call it basic operation. Now in this lecture, we are going to see how we can read and write from CSV file. So we have given this another file called order.csv. So if you open that file, it's a different data set. It has some kind of orders from some e-commerce company, etc., right? Country, order ID, etc. And we are going to load this data in Databricks. Okay. So we'll go to data ingestion here, and then instead of using create or modify table, we'll upload files to volume. Why? Because we don't want to create a table out of this CSV file. We want to upload this file as is here in Databricks. Okay. So click here and drag and drop this order files here. You will see what happens actually. Click workspace, default, and then you have to create a volume. So create a volume, let's call it raw data. Okay. And it's a manage volume. Okay. And create. Manage volume means like here we are uploading the data to Databricks, and Databricks is taking care of management. So click on upload, and once it is uploaded, go to catalog, workspace, default, and here see, in tables you have movies table, but in volumes you have raw data. And see, the CSV file is as is. We did not convert that to a table. Now let's create another notebook. So I think this notebook was basic operation, and this notebook I will call it read write CSV. Okay. And we already have Spark object, right? So you can just say spark dot read dot CSV, and here you specify the entire path and then df. Okay, it will take some time to run this code. Okay, so it read the file, but there is a problem. The header is considered as one of the rows in that table. Okay, so to tackle that problem, you can supply an option. You can just say option header is true. And when you do that, it will, the first row, it will take it as a header. Now you will see another problem. See, this order ID is integer, but here it says the data type is string. See, you can verify it, by the way, by also doing df.print schema. By this time, you already know about print schema function. It just prints the schema. Everything is string. Okay. So you can infer the schema as one of the options. Okay. So you can supply another option. So this is the syntax: spark.read dot option, in bracket you provide your option. If you want to supply another option, you again say option, right? Option dot, and here you supply the option, and the line is getting bigger. So let me just do this. So this way I can supply different options in different lines. Okay. So here you can just say infer schema is true. You want Spark to infer the schema based on the content in that column. So now you can see order IDC, it's integer. Then quantity, it is integer. Sometimes instead of letting Spark infer the schema, you want to specify the schema. You want to say, okay, order date is of type date, country is of type integer. Okay, so for doing that, you can specify the schema by writing this code. Okay, you don't need to remember all this code. You have AI assisted coding, so you can generate this code easily. So here from PySpark SQL, you are importing functions as f and types as t. And then you are creating the schema, okay, where you are saying, okay, my order date is of date type, my order ID is of integer type, and so on. Once you have done that, you supply another option called dot schema. It's not an option, it's a method. You just say dot schema is this particular CSV schema. And when you run that, see, it will take that particular schema. Now, sometimes you want specific format for a column. Let's say this is a date, right? You want it to be in a DD, YYY format. So once again, there is an option. Okay, so here you will have option called date format. And usually date format is like, see here I'm saying DD, YYY, right? So the date format, the usually accepted format is YYYY, and DD. And that is what we have already, but I'm just showing you. So see, like you have date, you have year, then month, and then date. Now, whatever we just did, you can do the same thing using little different syntax also, where you will say spark.read.format. Right, we were saying read.csv previously. See here, we are doing read and then CSV. Instead of that, you can say read but in format CSV. Okay, so this will do the same thing, it's just a different syntax. And then I want to write data frame to, let's say, Parquet format. For that, I can, you know how you have read function, you also have write function. See, and you can specify your format. So let's say I just want to write in a Parquet format. So I will say df.write.mode. Overwrite means whatever file you're writing to, if there is already a file present there, just overwrite. And here you will say Parquet and you specify the path. So in the same path, I will write this Parquet file, okay, orders. So it has written it. So now let's go to catalog, workspace, default, volumes, raw data, and here you see Parquet. So you see this thing, the data is now written in the Parquet format. We just worked on some basic data frame operations in Databricks, and you might be wondering, how is this different from running a plain Python notebook on my local computer? I can use pandas and do the same thing. Well, the key here is distributed computing. Databricks and Spark provides distributed computing, and just in case if you don't know what this is, let me explain this by a simple example of my own wedding. In any Indian wedding, food is a key highlight. So in my wedding, we wanted to prepare 2000 puris and we initially hired one chef. But then we realized that he's gonna take 4 hours, and what if he gets sick? You know, there is a dependency. So then instead of one, we invited 4 chefs and we gave them 500 puris each, and they worked in parallel, and we were able to make 2000 puris in 1 hour. Now, this is a common sense concept, right? You can make your work parallel and get it done in a quicker time. Similar thing, you can do it with computers. Let's say you have this data set where you have ticker, you have price and EPS, and you want to compute PE ratio. You can give it to your computer, right? You can run pandas code and you can compute it. But what if you have 40 million records? Your computer will probably hang, right? So what you can do to solve that problem is you can divide your data into batches and you can give it to different computers, and they will do all this computation and you can aggregate these results. Okay, so this approach is called map and reduce. So this is map step and this is a reduce step. So just to make it general, you have a bigger task you give it to your main computer, your driver computer, it will divide it into multiple tasks as if you have a team lead and they have 4 team members, and it will divide each of these subtasks to them. Okay, so this entire thing is called cluster. So you have your driver computer and your worker computers. Okay, so this is a driver computer, you have worker computer, and this is what is distributed computing. And one other benefit other than getting efficiency and speed is that, let's say something happens to this computer, right? It goes down, then this driver or team lead can assign that task to somebody else. So you get something called fault tolerance. It's similar to you're working in a team, one of your teammate is sick and your team lead will assign the task to some other team member, or they will hire a new person. Okay, so let's say, going back to my wedding example, what I can do is, if I want to prepare 2000 puris, see, previously I said I will hire 4 chefs, but instead of hiring 4 chefs, how about I hire caterer? And caterer can have multiple chefs. I don't care. I just talk to caterer. This person is a single point of contact for me, and as an output, I get 2000 puris. Okay. Now let's say if some chef gets sick or something, caterer will take care of assigning that work to some other chef. They will get new chef, etc. So distributed computing is the process of splitting the large computing task in a smaller subtask and executing them in parallel. Okay, so that work can be done efficiently, and the whole thing acts like a single system. So what is Apache Spark and Hadoop then? Well, Hadoop is a distributed computing framework, folks. It lets you do the same thing, but it is very disk heavy and slow. So when Hadoop was going through all these problems at UC Berkeley AMP lab, this person, Matej Zaharia, along with other people working at UC Berkeley, invented Spark. So Spark is a unified engine for large scale data analytics. It is basically a compute, okay? And it's an open source distributed compute engine designed to process large scale data quickly and efficiently. So it solved that problem with Hadoop. Hadoop was very disk heavy, and Spark does everything in memory. And due to that, it is very efficient. Okay, so if you look at this particular diagram, let's say you want to do this computation, you can write a simple code in PySpark. So PySpark is a Python module that helps you work with Spark. You can write a simple code that you read this talks.csv file and you simply divide it, right? You can say with column and divide these 2 columns that you have, and internally it will assign it to your computers and all that. You don't have to worry about the details of distributed computing. You focus on your business logic, where to divide the work, how many computers, like, all that details will be taken care of by Spark. So essentially you give the code to Spark and you set up a Spark cluster, and then this driver program will give the work and you will produce the result. So it is very similar, right? So Spark is similar to a caterer. So look at these 2 diagrams. It's very similar. Okay, so it's a distributed compute engine that abstracts. See, this is very important. It abstracts the complexity of parallelism, letting developers focus on a business logic. And it is very fast compared to Hadoop in memory and simple API. So what is Databricks then? See, if you want to run Apache Spark, you have 2 options. One is self-hosting. So you basically go to the Spark website, you download the Docker image, or you download the zip file, and you set things up on your computer. Okay, so this is like me talking to caterer, photographer, decorator individually, and even I will go and if decorator says, okay, I need this much stuff, I will go and get it from the market. So I'm also involved in this management. Okay, and this management means when you're doing self-hosting, you have to provision physical and VM nodes. You are installing and configuring Spark, Hadoop, Yarn, etc. So all this management of setting up Spark cluster and making it functional is involved in self-hosting. Instead of that, just imagine I hire an event planner. An event planner will talk to all these people and she will take care of all of those things. Okay, so there is less headache for me. So this is called managed service. So in managed service, you take away the cluster life management burden. You just say, give me cluster of X workers and it will do that. Okay, so this managed service is nothing but Databricks. So when you go to Databricks, you just create a cluster, you create a compute, and that's it. Everything else, all of these things are taken care of by that. Okay, so this is just a diagram highlighting the difference between the two approaches. Now we are going to run SQL queries in Spark, which is something you will do a lot either as a data engineer or as a data analyst. We already have movies dataset, and if you want to run SQL query on top of that, you can do it in two ways. The first way is, let me just create a markdown cell, SQL using Python API. Okay, so there is a Python API through which you can run this SQL. And we have Spark object already, correct? So on that, you can simply run spark.sql select star from workspace.default.movies, where studio is equal to Marvel Studios. Okay, and this is it. Now it will return a data frame. So you can say df Marvel, and here df Marvel dot show. So let's run this code. Okay, I got this error because I have quote here and quote here. So you can just use, okay, you can use a single quote here. Okay, let me do that. So single quote, and then double quote. You have to take care of these quotes in Python. You can also use triple quotes if you have a longer SQL query. See, it's wonderful, right? So we used Python function spark.sql, and you can specify your query here. The second way is SQL using %SQL. Okay, so in the code, when you say %SQL, you can now freely write your query. You can say select star from whatever. Let me just copy it, this particular thing here, and it will execute it. This sounds more like you're having your database tool, your whatever Oracle or MySQL Workbench, and you are directly running your query. See, and this result will be stored in _SQL_df, so that if you want to use it later on, you can use it. Now let me create a temporary data frame. So I'm not going to use any movies, which is table actually in Databricks. I'm going to create a data frame on fly for my weather data. So I have this Python array, okay? And in Spark, you can say spark.create data frame data. So you specify your data, then you specify your schema, and that will create your data frame, okay? And here I'm just doing some formatting for my date column. So when you run this, it will create a data frame for my weather data. Now I want to run SQL query on top of it. How do I do that? Well, you can do that by creating a temporary view. So you can say df create or replace. If you already have a view with name weather in your session, this will replace it. You can also say create view, but we always use create or replace temp view. Okay. Now when you run this, let me just show you what happens. Now you can say %SQL, and you can run a query on this view. So let me run this query, select event and average temperature, whatever, from weather. See, from weather. So this weather is this view that you have created, and group by event, etc. Okay. So now remember that weather is not a table in my Databricks. It's a data frame from which I have created this view, and the name is weather. And see, I'm able to run the query. So this is very cool. Now, if you look at other options for the function, see, it has create global temp view also. So see the scope. So let me say global weather. Okay. So this is session scope. What it means is, in my session, in my current PySpark session, in this notebook, this is valid. So if I go to a different notebook, and if I run this query, it's not going to work. But if I have done create global temp view, then on global_weather, I can create another notebook. It should be in the same cluster, but another notebook on which I can run my query. Okay, so that's the purpose. Now you can run the same query using Python API also, right? So here we are using %SQL, and for Python API folks, it's super easy. Just say spark.sql and your query, and that's it. So what we learned in this session is there are two ways
to run SQL queries in Spark. One is using Python API, which is spark.sql, and the other one is %SQL. As a data engineer or data analyst, you will be running all these queries a lot, either for ad hoc analysis or for your pipelining purpose. Let's now look at how you can perform joins in Spark. You can perform joins using SQL query or using Python APIs. So I have created a new notebook and I have two data frames that I have created on fly. First one is customers, second one is orders, okay? And here I have specified schemas, and then I've used spark.create data frame. When I display them, they both looks like this. So in customers data frame, we have one record where customer ID is null. In orders, we have reference to some customer IDs which are, let's say, null. And look at this 5 customer ID. It does not exist here. So this kind of inconsistencies will help us demonstrate the concept of joins better. The APIs look pretty similar to Pandas API. So here I can just do df orders dot join df customers on some column. So how does these two columns relate to each other? Well, through customer ID, okay? So in orders, you have customer ID, and see customer ID is a primary key in this table, and you can join both of them using this customer ID. To be explicit, you can specify the name of the parameter. So you will say on customer ID. And how do you want to do it? Well, there's a parameter how, where you will say left join, right join, inner join. By default it's inner join, okay? So df inner and then display df inner. See, it performed a join. Now inner join means you should have that customer ID in the second table, which is your customer table. Otherwise you will not see the row, okay? So if you look at both the tables here, you will notice that in the orders table, this particular row, right? See, this customer ID is not present here. Also, this customer ID is null. You can't say null is matching null here, okay? Null means nothing. So this is also not matching. So only matching rows are 1, 2, 3, 4, 5, and 6. So you have only 6 rows. So when you perform inner join, these rows with order ID 104 and 106 will not be displayed. See? So here you don't see 104 and 106. Okay, so that's what is inner join. If you do left join, okay, so let me do left join and see what happens. From your SQL concepts, you know that left join will keep all the rows on the left table. So left table is ordered table, okay? So order table have order ID 101 to 108. So it will keep all of that, see? 101, 2, 3, 4, 5, 6, 7, 8. It will keep all of that. And in a customer table, if it doesn't find something, right? See, for this null customer ID, it did not find anything. So these 3 are the columns from customer table, and put null here. So similarly, you also know like how right join performs and so on. Now, one thing that will help us write our queries better or perform our join better is this concept of alias. So when you have this data frame and when you do alias O, so this will now, this O is nothing but it's just another data frame that you have created. It's exactly same as this one. But this alias O is similar to the alias that we use in SQL queries when you're performing joins. Also, when you're performing join with the same table, this kind of alias will be useful. So let me create alias for both our customer and order, okay? And now with that, you can perform the same join that we did here, right? The same one, but you can use now the alias, okay? So this is pretty kind of simple. But let me show you another query where this is particularly useful. See, here, when you look at all the columns, the country column is kind of common in both of the tables. And this is creating ambiguity. You don't know which table this country column refer to versus this, right? So you want to say, okay, this is my orders country or shipment country, you know, from where you are shipping it. And this is my customer country. So how do I do that? So the first thing I will do is this. See, let me do this. And let me create a new data frame called df inner clean. And whenever you want to write multi-line code, you can use this kind of bracket. Okay, so that will help you. Now you can say dot select, and here you can specify the columns that you want to select. So I want to have, see, customer ID, order ID, amount. Okay, see, customer ID. Okay, let me just remove this. What I want to have is order ID, then customer ID, amount, country, name, and VIP, right? Now these two country columns are something we need to disambiguate. So let me just pull them in the new line. Now I'm going to say f.call. See, it is doing autocomplete. So f.call order.country is order country, or you can just say ship country. Okay, and do the same thing. Okay, let me remove it. Do the same thing for this, but this time it is customer country, right? c.country is cust.country, and then you will say display df inner clean. Let's run this. Control enter is the shortcut that you use. See, now you clearly know that this particular column belongs to my order table, and this column belongs to my customer table. The value of how is either left join, right join, inner join, or full join. So let me just show you the full join here. So full join will show you everything. It's like a union between two sets. Okay, so you can say display this, and here I will have full join. So let's see what we get. Okay, we got 10 rows. Why 10 rows? Because it will give me all the 8 rows from the order table, right? All these 8 rows. And then on the right hand side, if you check, there is this row with customer ID 4, and we don't have any order here, but it will also show that. And there is another row with customer ID null. So 8 and these 2, right? So all 8 rows it will show, and it will show also these 2. Therefore you have 10. So see, last 2 is Ghost and Dinah. You see Dinah with 4 customer ID, and this is Ghost. And for this you don't have any order, so these values are null. See, null, null, null. And for this particular row, you don't have any customer information, so you see null. See, you see these 3 null. And for customer ID 5, we don't have any customer ID in that table. So here also you are saying this 3 null values. So that is the behavior you get by performing the full join. Now there is another kind of join where you say left semi, and what it will do is it will show you orders with a known customer. What it means is known customers are only these, right? 1, 2, 3, 4. So 1, okay, so 1, okay, 1, then 2, then 3. So how many rows? Okay, this many, right? 6. 1, 2, 3, 4, 5, 6. So you will get 6 rows. See, 1, 2, 3, 4. This is different than left, right? Because if it was a left join, you would have also got this 5 row. But here you don't get it. So that's why it's called left semi, which is orders with known customers. And exactly opposite of this is left anti, which means exactly opposite. Basically, you get all the records from the right hand side table, okay? Or rather, see, customer 5 is not present in customer ID table. So it will show you that, see, customer 5, you see, and then it will also show you null, this null. So whatever customers which are not present in the customer ID, it will show you that. So it's an exactly opposite of left semi. You can also perform join using a composite key or multi-key. So let's say I want to perform join using customer ID and country. Okay. So when I do that, I get 6 rows. Okay. So here, see, customer ID is 1 and country is this in, right? So 1 and in. So it will perform join with this particular record, Asha. Then you have 2, and for 2 you have US. So 2 US. So it will perform that. Then 3 you have Canada. So 3 Canada. CN. Okay. Canada or China. I don't know what it is. But this is using multiple keys to perform the join. All right, that's all I have. You can do much more, but this is good enough for the basic tutorial. Spark is popular because it has a lot of internal optimization. In this chapter, we are going to understand the internals of Spark so that we can understand why Spark is so widely used in the industry. And this understanding will help you with interview questions as well. Okay, so this entire chapter is very important from the interview standpoint. In this particular lecture, we are going to talk about reading Spark plans with .explain. If you have used SQL, you know that in SQL, if you want to look at the query plan, you use explain. Similarly, when you are writing queries in Spark, there is this .explain function that will give you the internal execution plan. I will directly execute the explain method and will read that plan. So I have read the movies table. You know, we have used this table before. And here I am running a query to get all the movies which has release year greater than 2010. And then I am getting only 3 columns out of it. And I'm calling that df narrow column. Okay. Now see, our data set is small. But let's say if this data set had millions and millions of records, it's going to execute them on multiple nodes or multiple computers. Okay. So it needs to do some kind of optimization. So here, when you run df narrow.explain, this method now takes a bunch of parameters. See, if you don't supply anything, it is going to print something called a physical plan. I'll tell you what physical plan means. But if you say extended, it will print both logical and physical plan. So that sounds interesting. So let me print that and then I will explain what it means. So extended, okay, and control enter to execute it. So see, it printed this particular thing, which sounds interesting. It has parsed logical plan, analyzed logical plan, optimized logical plan, and a physical plan. Okay, so let me explain what this thing is actually. So when you write any query, right? See, we use Python API to write that query, but you can also do %SQL and write that query. So when you say select ABC from table X, what you have is unresolved logical plan. And then you will use catalog. So catalog has information on your databases, table, etc., which will create your resolved logical plan. Okay, so here, let's say if I say that select, you know, in unresolved logical plan, if I have select ABC columns from table X, that is my unresolved logical plan. But when I convert to resolved logical plan, it will look into catalog to see, okay, do we have actually X table? And if we have that table, do we have ABC column? If they are not there, then it will throw the error. If they are there, then it will modify that query plan. I'll show you what it will do. It will put like IDs and stuff to make it more concrete. After that, it will create optimized logical plan using logical optimizer. So similar to how you will optimize your SQL queries, you will optimize your resolve logical plan, and I'll show you exactly what it will do underneath. Then you convert that to a physical plan. Physical plan is basically how do I take this query and distribute it to my multiple nodes so that I can get the best results in a minimum amount of time. Okay, so it will come up with 2-3 strategies or n number of strategies. Okay, that number can be anything. And then you will use cost model to figure out which plan is going to be the best in terms of your performance, your compute cost, and so on. And then you get the best physical plan, and that best physical plan is something you will send it to your cluster for execution. Now here I have mentioned AQE, which is adaptive query execution. We will talk about it later on in this chapter, but just consider this green box as an evaluator which can figure out, okay, which plan is the best. and then it will send that plan to cluster for execution. Now from unresolved logical plan to optimized logical plan, there is a component called Catalyst Query Optimizer which will come in play, and it will help you create the optimized logical plan. Okay, and when it comes to execution, see, here we are just creating a plan, we are not executing it. The execution happens here in the last block. At that time, we will have Photon Query Engine, which is a high performance vectorized query engine written in C++. It is relatively modern, and that will make sure that your query gets executed really fast. If I have to summarize things differently, you have SQL query. So the role of Catalyst Optimizer is to create optimized plan, and the actual execution. See, remember, Catalyst Optimizer doesn't execute. It is just doing, optimization. It's like you're sitting in a room and you're trying to figure out, okay, it's like going to Google Maps and figuring out different paths, okay, from city A to city B. These are the 3 different paths. So Catalyst Optimizer will just optimize, it will create the best route from A to B. And Photon Executor is actually you're taking a car and you're going from A to B. Okay, so I hope you're getting this point. So let's look at past logical plan. Past logical plan is nothing but your unresolved logical plan. And with the help of catalog, you are getting resolved logical plan, which is this analyzed logical plan. Okay, so see, here you are doing filter on release year 2010. Okay, and project means select. Project simply means, see, whenever you see project, it means select. You are selecting only 3 columns. Okay, our movies table has many more columns, but we are selecting only these 3 columns. Okay, and unresolved relation, which means you are saying workspace, default, and movies. That is unresolved. Okay, so here we don't know whether you have this table or not. Okay, because we are in an unresolved logical plan. Now with the help of catalog, we are creating resolved logical plan, which is this. So now we looked into catalog and we said, oh yeah, there is a table called workspace.default.movies. See, so it found a table and then it assigned all these IDs to the column. See, these are the IDs which will identify the actual physical columns, and it is in a Parquet format. And then out of all these columns, you are interested in only these 3 columns, right? See, title, studio, and IMDb rating. Why do I have the 4th column? Just pause the video and tell me. Well, we have 4th column because we need it for filter purpose. Okay, so that is the reason we have 4th column. And then you are doing a filter. Okay, release year should be greater than 2010. And after doing the filter, you are selecting only, see again, folks, project means select. So you are selecting only 3 columns, right? So we had 4 columns, but in the final output, we are selecting these 3 columns. So that is your analyzed resolved logical plan. Okay, analyzed logical plan and resolved logical plan is the same thing. Now you are applying optimizations and you create optimized logical plan. So let's see what kind of optimizations we applied. See here, what we did is we had this table, right? So in this table, we had all these columns. We applied filter. So first thing we will do is we will apply filter. Why? Because that way you are reading less data. See, if I read all the data and have it in memory and then filter, then see, eventually I care about filter data. So the extra rows which were movies which were released before 2010, I read it in vain, right? It was not useful. So here we are applying a filter, but notice this, we are also checking is not null, because if it is null, then it's not going to be greater than 2010. So we can ignore it. So this is one condition that is added by our optimizer. And then you create the best physical plan. So the best physical plan is nothing but this physical plan. Okay, so let me just scroll. Okay, so I hope you can see it. Now let's check this. So you have to always read from bottom. So when we are looking at this particular thing, read from the bottom. So see, it is doing photo scan. Again, Photon is your actual executor, it's a vectorized query executor. So it went to your table where the data is stored in Parquet format, and what did it do? Okay, so it will scan all these columns. See, only 4 columns. See, it is scanning only 4 columns. It's not scanning all the columns. And then it is applying all these filters. Okay, format is Parquet, location is, say, this S3, actual location of the table that you're reading. Okay, it can be table, it can be file, anything. And then there are a bunch of parameters here. All right, so I hope you're getting some idea. Folks, it might be overwhelming. You get some understanding, don't worry. As you progress, as you work with this more, you will get better understanding. So I'll encourage you to write some different queries here, then print the plan and talk to ChatGPT. If you don't understand what it means, then give your code and your plan and say, hey ChatGPT, can you explain this step by step? And it will explain you. If you don't want to print the entire plan, then you can print something called formatted. So formatted. So this will print only the physical plan. Okay, so let me just copy this, or we can just read it here. Okay, so see, when you have formatted plan, is much readable. So let me go over physical plan once more with the formatting. So see, first thing it is doing is scanning your tables, then it's doing project, means is selecting, and then there is a result stage and columnar to row, because see, when you're printing these results, right? See, when I say, let me just show you here. When I just say display this, here you need the results in a row format, right? But in a Parquet, it is stored in a columnar format. See, here is rows. So you have to convert the columns to row. So that is the final stage. Okay. So see, the first operation was reading those 4 columns. So right here, it applied that optimization. And this is the beauty of Spark. Okay. It will only read those columns which are required. Then it applied filters. Release year should be greater than 10. Okay. Now see, it applied filter even before select. See, in our code, we have select first and then we are applying a filter, right? But here it optimized it and it is applying the filter first. Okay. And then out of these 4 columns, it knows that it needs only 3 columns. So it will read only 3 columns in the next stage. So in a photon scan, it will just read these 4 columns. And in project, which is select, right? So in project, it will get 4 columns, but in the select, we have only 3, right? Release here, we are using only for the filtering. So it will read only 3 columns. See, input is 4 columns, output is 3 columns. I hope you are getting it. And in the result stage, it's the same thing. And then columnar to row, which is converting from columnar Parquet format to rows. That's all for this lecture. In the subsequent lectures, we will further dig down into this. We will now understand Spark architecture. We just saw this code. In this code, when you call df.select and filter, it will build that plan, that optimized plan, and then it will convert it to a physical plan. And when you call count, it will actually execute that plan. Okay. So what happens is, in Spark, we all know it's a distributed computing. So there will be multiple computers working on this. In our case, movies data set was small. So maybe it executes everything on one node, but let's assume that movies data set is very big, like 10 gigabyte of data. So in that case, wherever you are running this notebook, okay, your notebook kernel, wherever it is running, that computer is called driver. So it's a main computer orchestrating the whole thing. Okay, so let's call it node A. Node A means a computer in cloud. Okay, it will build a physical plan. So it will take, whatever we discussed in the last lecture, take the logical plan, optimized plan, physical plan, and so on. Then it takes the data set, and the data set will be divided into partitions. So let's say, for simplicity, let's assume this data set has 100 records. Then P1 will be, let's say, 40 records. P2 is 40 records. This is 20 records, and so on. Because it's a distributed computing. So you are going to use multiple computers to execute this code. And then there will be executor nodes or worker nodes. Let's assume we have 2 nodes. Okay, there can be many. I'm just taking example. Node B and C. And now node A will give one partition to this, and it will also give a task. Okay, so let's say this task is T1. So the task here is to filter using release year. Okay, give me all the movies greater than 2010, who has release year greater than 2010, and then pick these 3 columns. Okay, so that is your task. Okay, that code is your task. So when you run T1 on P1, you will get another data frame, right? And that data frame, let's say this guy had 40 records. Let's say this has 15 records, because you are doing filtering, right? So you'll get less records. Then it will give P2 to here. And eventually it can give P3 to either this node or that node, right? One of the node it will give. And let's say on this, it runs task T2, which is again release year greater than 2010, and pick these 3. And let's say it gets another this narrow data frame, which has only, let's say 10 records. And then T3, okay, 20 records. So after the filtering, let's say you get 3 records. So now all these partial results, it will send back to driver when this is called. Okay, when df.narrow count is called, that is when this whole execution begins. So Spark has this concept of lazy evaluation, which we'll talk about in detail in the next lecture. But it will, until this point, when you say df narrow, until this point, second line, it will just create a plan. And when you say dot count, then it will actually execute this plan. All these results are sent back. Okay, so let's say 15. So this guy sends back 15. This guy sends 10 and 3, 10 and 3. So 25 and 3. So this df.narrow count, so this driver node will now display 28. Okay, so talking in general terms, you have a driver program where Spark context or Spark session is created. We also, in Databricks, we get this object Spark, right? Remember, we created Spark.table movies, whatever. So the Spark variable is a Spark session. So driver program creates Spark context or Spark session. Then it communicates with all these worker nodes. Okay. And these worker nodes can be any, it can be 10, 20, whatever. And then to create the worker nodes, to kind of manage those, it uses cluster manager. Now this cluster manager can be Databricks managed, Yarn, Kubernetes. You know, if you have worked in orchestration, cluster management, you might know. So cluster manager will take care of creating new node. Let's say if one node fails, you know, what to do with it. So that node lifecycle management is done by cluster manager. But the actual task assignment is done by driver program. So I hope you got a good understanding of Spark architecture. It is a very commonly asked question. The interviewer may ask this question that, okay, explain Spark architecture, and you can just draw this on a whiteboard and just explain the whole flow. Let us now discuss transformations versus actions and lazy evaluation. We have looked at this notebook before. Okay, here when you create df narrow data frame, you are using some transformation. You are doing filter, then you are doing project, which is just selecting 3 columns out of many. Now, when you execute this cell, it doesn't actually create df narrow data frame. It will only create a plan. It will execute this code and create a df narrow data frame when you call display or when you call df narrow.show. So Spark has this lazy evaluation where when, let's say, if you're running this code in pandas, Python pandas, it will execute this code right away and it will create a df narrow data frame. But in Spark, it will not create df narrow data frame with all its data. Okay, it will create that variable, but this code will not be executed. It will only create a plan, and it will follow this lazy evaluation and delay the actual execution of code until this display is called. So essentially, whenever you're doing transformations such as filter, select, etc., all these methods are called transformation. And when you actually execute the code, right, things like .show, display, these are called actions. The example of transformation functions are select, with column, filter, where, etc. So whenever you call all these methods, or okay, there are more actually, I'm just showing you a couple of them. it will not trigger the code actually. It will just build a plan, okay? And these are called transformation. But when you say dot show, see, at that time you are showing the results, so it has to be executed. When you say count, right? 2 pandas, when you're writing to disk, let's say you are writing data frame to disk in a Parquet format or CSV format, whatever, you have to execute the code, okay? So it is like transformation is a recipe that chef is preparing. So let's say they are preparing recipe for Rasagulla, or they are preparing the recipe for Hyderabadi biryani. They are just noting it down, okay? But action is like cooking that recipe, making that Rasagulla. So I hope you understand, like with this analogy, transformation is just building a recipe, actions is actually cooking the food, right? So here, all these functions will only build the plan, right? The physical plan. And all this action will actually execute the plan. So the definition here is transformation is an operation that defines a new data set from existing one, but does not execute it immediately. Whereas action is an operation that triggers the actual execution, okay, and returns a result. So action will either return a result, okay, to the driver program, or it will write data to data storage. Now let's understand, why do we do lazy evaluation? There are a couple of benefits. The first one is query optimization. Just look at this query. If you have eager execution, which is if you're executing at every step. See, right now I'm showing one line, but many times you can have df1 is equal to df.filter, then df2 is equal to df1.select. People do that. So if you don't have lazy execution, then what will happen is it will first filter on age greater than 18. Then let's say this data frame has 5 columns. Now it will select only one column, select name. And then it will filter on column name not equal to blank. But if you have lazy execution, you will build a plan, okay? You will not execute until you call df.count or df.show. So when you create the plan, okay, of this entire transformation, then instead of running 3 separate transformations, you can combine both filters into one, right? So you have 2 filters, right? Like this one filter and this. You can combine them into one. And you can push down filters to the data source. So let's say when you are creating this data frame, right at that time, you can apply this filter. So instead of reading like 10,000 records, you are reading maybe 200 records from the disk. Then only read name and age columns. Let's say this data frame, when you're reading from disk, it has 40 columns. But in my code, I'm using only 2 columns, age and name. So in that case, I can optimize on these columns. You can also avoid unnecessary work. See here, I'm showing only first 5 rows, right? But let's say if you're running this in pandas, and if let's say this is a huge data frame, this might contain million records, right? But in PySpark, what will happen is it will not execute the code here. It will execute code only here. So now it knows that, okay, user wants only 5 rows. So it will execute and it will just show you 5 rows. It is also memory efficient. The opposite of lazy execution is eager execution, right? You are just executing it every time. So eager execution, if you're doing, I'm just giving this example where you have a file of 1 gigabyte, and let's say you are reading it into a data frame. So that's your 1 gigabyte data. Then you are applying a filter. Let's say this is df1, now you have df2, right? This is df1, this is df2, df3. So you have 3 data frames and it will store 1.7 gigabyte. But with lazy execution, it will create a pipeline, okay? 1 GB filter, select and result. So with that, it will occupy much less memory. It is also fault tolerant. See, this is the beauty of Spark. It provides you fault tolerance. We saw this example before, right? And in that case, let's say node C, okay, fails due to whatever reason. So node C executed 2. Let's say it executes this task 2 with P2 fine. Okay, there's no problem. But after some time, when it executes task 3 with P3, let's say there is a problem. Node C is down, let's say. It goes down, crashes, something. Now the driver knows, driver is orchestrating the whole thing. It knows that this is failing. So what it will do is, it will assign this task to another node. See, either it will assign the task to this node or it will spin off the new node based on how you have configured things, okay? But since it has the entire plan or entire recipe, see, this is important. When you have entire recipe, now you can take the recipe and data set and give it to someone. It's not like you have a half-cooked recipe, right? It's like you have a chef, right? Let's say this is a chef. So remember the chef example that we discussed before. This is the main chef, master chef, and these two are different chefs. Now, let's say this chef has cooked some recipe, okay? They are creating a vegetable biryani. They have cooked vegetables and they have not mixed rice yet. And let's say this chef falls ill and he has a problem. Now you don't want to give this half-cooked recipe here. Since you have the entire recipe, this master chef will give that entire recipe to a new chef and say that, okay, this is the recipe, these are my raw ingredients, prepare it. Rather than giving this half-cooked recipe to someone, right? It becomes a problem. So that is the beauty of creating this physical plan. It gives you a fault tolerance. So these are some of the benefits. There are more benefits as well, but you have to just remember that with lazy execution, you get all these benefits. And also you need to remember the difference between transformation and action. Transformation is something that will just create a transformation. It will not actually trigger the action. Action is something that will actually execute the code and give you the new data set or new result set, or it will write it to a disk. Let us now discuss narrow versus wide transformations. The example that we saw before, where you are just filtering on data and selecting bunch of columns, is narrow transformation. Narrow transformation is a transformation where you don't have to exchange data between different nodes. So here, let's say you are getting in partition 1, you are getting total 40 records, right? And these 40 records have title, studio, IMDb rating, release year, etc. Now what you will do is, when you run task T1, you will first filter these records, right? So now to filter the record here, you are looking at release year. So let's say from 40, you get 15 records. So you are working on this P1 set only. You don't have to check P2. And then from that 15 records, let's say these 15 records, originally movies table has 10 columns. So these 15 records will also have 10 columns. Out of that, you are picking only 3 columns. And same thing for P2 and P3. You don't have to go to a different node to execute your task. But what if you have operation like this, where you are first filtering, but then you are grouping by studio. And then you are calculating average revenue of every studio. Let's say Marvel Studio is this much average revenue. Yash Raj Studio is this much revenue, and so on. Now in that case, you will have to look at data on different nodes. So let's say first you filter down data using 2010. So let's say you have filtered it. Okay, so you filtered here, here, and here, and you got all this new data set. But now to perform group by, you have to look at all these 3 data sets. Okay, so maybe some different node, or let's say node B is doing group by. Now it has to get this filtered data. Okay, this data and this data needs to go to this node, and this node can perform group by operation. Same thing with sorting, right? If you're doing sorting, etc., you have to go to different node to get the data, and this is expensive. Okay, this is going to slow down performance, but we don't have any other option because there will be data transfer between different machines. So narrow transformation is each output partition depends on a single input partition. Okay, so there is no shuffle essentially. Whereas wide transformation, output partition depends on multiple input partitions and requires shuffle or exchange between the stages. Okay, so these are the examples of narrow transformation. You want to filter on certain column, you want to select certain columns, you want to create a new column, map type of operation. These are all narrow transformation. Wide transformation, on the other hand, is group by, order by, join. For all these, you need all the records. With a subset of records, you can't perform this operation. So these are some of the common operations for narrow and wide transformation. Now, in my notebook, I performed this particular transformation. And since this is running on serverless compute on Databricks, I had to set explicit partition and also I had to call repartition, okay? But this code you can ignore. This is just for serverless compute on Databricks. Here we are getting average revenue based on the studio. And in the plan, right, when I run plan, explain, the physical plan will have things like, see, shuffle exchange. You see shuffle exchange? So it is doing shuffling and exchange because we are running Y transformation. Let's now discuss very important topic of partitions and parallelism. We have seen this particular diagram before, and we all know that Spark works on a distributed computing principles. And here, this P1, P2, P3 are the partitions. So partitions is a unit of parallelism. It is not just a data partition. Here, you will have a corresponding task. So P1 will be processed by task T1, P2 will be processed by task T2, T3, and so on. So partition can be considered as a unit for compute, parallel compute. Now, we have seen this example before, right? Where if you want to prepare 2000 puris, you can have 4 chefs, each preparing 500 puris. What if someone decides to have 2000 chefs? 2000. Is it good? No, right? Because then one chef is preparing 1 puri and it's not cost efficient, and also you have to do a lot of coordination. Also, what if you have only 1 chef? That is also not good, correct? So whenever you are doing parallel processing, number of partitions that you have or number of parallel tasks that you are running is a number that you have to decide with a lot of care. You know, you need to keep a right balance. You don't want to have too many workers. You don't want to have too less workers. Okay. So when you have this kind of architecture where you have, let's say, 3 computers and each computer is having all these partitions. And by the way, every computer can have multiple partitions. Okay. You want to keep a right balance. And to maintain this balance, we have a couple of functions. The first function that can help is repartition. Let's assume this scenario. You are grouping by studio for our movies dataset and you are calculating the average revenue per studio, right? So you are calculating, let's say, for example, my Marvel studio has average revenue of 20.5 billion. My Dharma production has average revenue of 6.7 billion, right? That is what this line will do. And here you have all these partitions. But what happens is when data frame is created, right? Like, see, this is very important. We need to visualize this. Where is my DF, right? This DF. Okay, tell me, where is my DF? This data frame that I have, where is it? Well, this entire thing is my DF. See, this entire thing, right? Let me just, I wish I can draw a good diagram. So this entire thing, this thing is my DF because it is distributed, right? If it has 1000 records, it will be distributed across all the machines. And Spark provides you abstractions so that you don't have to worry about all these details, right? You can write a code df.groupby, but internally it will be divided between multiple nodes. Now, when you run group by, what may happen is, see, let's say you are running group by, you want to find Marvel's revenue. Marvel can be present in all these records because when you partition, you did not partition by studio, right? The partition was done maybe in a round robin fashion or maybe by using some other strategy. So now, see, this is my DF, right? Now you're creating a new DF called revenue DF. So what will happen is, let's say I have 2 records of Marvel here, okay? Or let me just draw them with a different color. So let's say this green is my Marvel, right? So let's say I have 2 records here. 1 record here. This doesn't have a record. And this has 3 records. This has 4 records, right? And this doesn't have it, and this has 1 record. Now it will have to do data movement because to calculate revenue, average revenue of Marvel, it needs to access all these records. So to generate revenue DF, it will have to do all the data movement, correct? So it might, let's say if it is running this operation on node A, it will, these data all these records will be moved here. And data movement is always expensive, right? So that's gonna hit performance, folks. Okay, now I get all the Marvel records, and I can now create a partition for revenue DF, by the way. So similarly, you will calculate revenue for Dharma Production, all other studios, right? And how you had DF between P1 to P6 partition, you will have your revenue DF also in multiple partitions. Let's say you have a huge data frame, right? Revenue data frame is also huge. Then we can call this partitions, let's say PA. So you might have PA here, PB here, and maybe PC here. Let's say only these many partitions are needed. So in this case, your revenue DF is this. See? This whole thing. Sorry for the bad diagram. But this whole thing is a revenue underscore DF. And since this data movement is costly, repartition helps you optimize this. Okay. So when you do df.repartition, see here. So again, my DF, this P1 to P6 is my DF. Okay. So this is your original DF. Now when you do df.partition 6 studio, so what I'm saying is create 6 partitions. Create 6 partitions. Okay. I think, okay, P3, P4, actually 7. I mean, the original one has 7 actually. See, this is P4, the numbering is wrong. This is 6, 7. There are total 7 partitions. So when I say df.repartition 6 studio, what it will do is, it is like a hashing operation. It will do partitions so that studio is present on a single node, basically in a single partition, right? So here, so let's call these partitions as x1, x2, etc. Okay. So here, let's say by studio. So every records for one studio will be in one partition. So if I have one partition here, x1, this will have all the Marvel records, let's say. And partitions are big, so it can have multiple studio also. Let's say it has Z studios. Then x2, let's say it has a Columbia Pictures, right? Then x3 has I think Yash Sharma Productions, right? So now again, one partition can have multiple studios, right? So what happens is, now when you group by studio and when you run this aggregate operation for revenue, it doesn't have to do data movement because the records for single studio are present in one partition on the same node. So now it can quickly do that aggregation. And by the way, this x1, x2, x3, etc. will form new data frame. So that is base, right? So let me just show you that. So this, right? This data frame is your base. Base is just a name of a data frame, right? It can be anything, df1, df2, etc. So in Spark, data frames are immutable. So once you create it, you can't change it. You can only create new one. So I had df, my original data frame for movies records. I created base when I did repartition into 6. Okay, so 6 partitions. So it will actually create 6 total partitions. So x4, and number of nodes doesn't matter. It can be x5, x6. Okay, so it will create 6 partitions, but it will make sure that the records from same studio so will be available only in a single partition. So all the records of Marvel Studio will be in x1. You will not file any Marvel record in x4, x5, x3 or any other partition. Okay, so that's a key thing that we have to remember. This is also useful when you're doing multiple operations. So let's say, see, I am doing group by studio, then I am running window operation on studio. So here I am ordering movies within the studio based on the revenue, right? So if I know that I'm going to be doing multiple operations based on studio as a key, then it's better that you create this data frame which is optimized for studio by key operations. Okay, So this is where the skill of data engineering comes in play, right? Like you are sensing that you are doing operations based on studio key. Therefore, let me repartition first and then do it. See, if you don't do repartition, if you do df.group by directly, it's going to work, but it will be slow. All right. So this is where the skill comes in play, and this is where you can perform in the interview, right? If you know all these internal details during the interview, you'll be able to answer those questions. So let's see this entire thing in action. I'm going to go to my workspace and I have this folder Spark internals. So let me create a new notebook here and I'm going to call it Repartition. Okay, let me hide this. The data frame I'll create in the same manner that we have done last time. And then I will also do, I just want to know how many unique studios I have. So you can run SQL query by writing this, right? So just say select studio from, or actually distinct, select distinct studio from workspace.default.movies. Okay, and see, I get 22 rows. So there are total 22 unique studios. Number of records are 37. So this is a very small data set that we have. But let's run repartition function. You're specifying number of partitions, and as an option, you're specifying studio, right? So this is repartition by key. And when you look at this, see, folks, it's another data frame. It will look similar to this one, right? Maybe number of the record order might change, but it's the same data frame. But what I want to do is I want to run explain. And in explain, what you're seeing is, see here, first it is doing the scan. Okay. Then it is doing this hash partition. Folks, so this is important. Studio is a key. And if you have studied hash functions, it will do hashing and it will try to put the records for the same studio in a same partition. Okay, so that's how this hashing function will work. Also, if you don't specify the key, it will do partitioning, repartitioning in a round robin fashion. So, okay, so this is a repartitioning by round robin. That's why I have RR. And let's say you are doing explain, right? So see, here, if you look at it, the repartitioning, let's see where it is. See, round robin repartitioning, and it is dividing it into 6 different partitions. And if you want to verify, you can write it to Parquet file. So I will write it to Parquet file, okay, and I'll verify it. And for this, I will create a new volume called this. So let me create a new volume by going to data ingestion. So data ingestion, remember we have created volumes before. So right now we have workspace default and we have only this raw data volume. Just for the separation, I'm doing this. So repartition demo is my volume. Okay. So when you create it, what happens is you get to catalog, refresh, default, and here you find this repartition, right? So this is the volume, and in that volume I'm going to write the records. So it will write it in a Parquet format. I think the name should be partition demo, and I'm here saying repartition. So let me just do repartition. Okay, and run this. Whatever is the name here, you should give that name, folks. It's a common sense. Okay, I don't have to explain that. Okay, now let's refresh this and let's see what we get here. See, watch this. There are 6 files. See, 1, 2, 3, 4, 5, and 6. Right? So that shows that this repartitioning worked. All right. That's all I have for repartitioning. Just to summarize, you have to repartition based on your use case. Okay. And repartitioning will allow you to perform your operations in an optimized way. There is another function that will help you do similar things, and we are going to discuss that in our next lecture. The second function is Coalesce. So let's say you have this kind of scenario. Okay. Now, usually you have one task associated with one partition, right? So here, P1, so there will be task T1 associated with P1, T2, T3, and so on, right? And then there will be, let's say this machine has 4 cores. So each CPU core can work on these processes. And this will work okay. But let's assume you have only a single core machine. I mean, that's not the case nowadays. Nowadays you have 4 core or more. But let's assume you have only single core, okay? So in that case, you are unnecessarily creating this partition, okay? Maybe there is a chance for some optimization. And that's what Coalesce will help us with. So when you say df.coalesce, see this df, this is the df, right? This entire 7 partition is a df. But when you do df.coalesce, it will reduce the partitions, okay? It will reduce the partitions. So total partitions that it will reduce to will be 3. So it will figure out the best strategy, making sure that there is a minimum data movement. So if I want to create 3 partitions out of these 7 partitions without moving data, what is the best strategy? You tell me. Well, it's easy, right? You just merge these. You merge this and you create this new partition. You merge these 2 and you create this new partition. You merge these 2, create this new partition, right? That's the best strategy, okay? So let's say you call this X1, X2, X3. And let's say this data frame is X. So X is equal to 3, this. So this whole thing, right? This whole thing becomes my X data frame. I hope you're getting this point. What happens when you do Coalesce 2? So remember, Coalesce is used to reduce the number of partitions. And when you have 7 partitions and you want to create only 2, what will happen? How do you do it with minimum data movement? Well, see, one way, if I ask you to use your common sense, is okay, you merge all this and you create one partition X1, right? Then the second option is either you move these here or you move this here. See, Coalesce minimizes data movement. It doesn't prevent it completely. So maybe I'll move P5, P6 here, okay? And I kind of merge it, okay? So I merge all this and create another big partition called X2. All right, so 2 means now my resulting partitions are only 2. What if I do 6? See, this numbering is wrong. This should be P4, P5, P6, P7. I have 7 partitions. I want to create 6. How do you do it with minimum data movement? Well, so you merge any 2 partitions on a single node. So you can merge these 2, or these 2. Maybe I'll merge these 2, right? So now this is X1, X2, X3, X4, X5, and X6. So see, I got 6 partitions. What if I do 10? Well, Coalesce can only reduce partitions. It will never increase it. So in this case, it will do nothing. Okay. So remember, Coalesce is used to only reduce partitions. It will never increase it. Now, what are the benefits? Let's look at some of the use cases. Coalesce will eliminate task overhead from too many small partitions. So let's say I have 4 cores, okay, 4 CPU cores on each of these machines. And I created, for example, 50 partitions each, right? Like I created 50, 50, 50. And with each partition, you will have a single task. So it will have to do a lot of task distribution. It's like hiring 1,000 chefs for preparing 2,000 puris, you know? So a better strategy might be, let's say, see, if there are 4 cores, I will not do 3, I will do 4, 4, 4. So I will do Coalesce 12. So I will create 12 partitions. So I will create X1, X2, X3, X4, X5, 6, 7, 8, 9, 10, 11, and 12. This way I'm utilizing all my CPU cores, okay? In parallel, I can run everything and get the efficient results. The second benefit is it will optimize file output. So let's say you have a data frame with 1,000 partitions, and when you say df.write.parquet, it will actually write 1,000 tiny files. It's not efficient. it will write one file per partition. But you can do df coalesce 10 write and it will create only 10 files. Third benefit is it is minimizing data movement. So as you work on the projects, as you work on Spark more, you will realize that sometimes you have to use coalesce function, sometimes you have to use repartition. Okay, so you have to use it wisely based on the use case, and that is where your skill will come in play. Let's quickly go over the concept of managed versus external table. When we created our movies table, and if you go to details, you will see that the type is managed. Now I know you're not seeing this company stocks or support logs table. Don't worry. As we move ahead, we are going to create this company stocks table. And if you look at this table, it is an external table. So what is the difference between the two? See, when you look at any table in Databricks, it has two components. One is data and the other one is metadata. So what you see in the details here is metadata. Okay, created it, who created it, what is my storage location, all this information. See, properties, this is called metadata. And another way of looking at metadata is you go to SQL editor and you type this command, describe extended this. And when you run this command, you will see all this metadata. Once again, see, created by, command, is managed location. So for managed table, Databricks will manage both the content and metadata. All right. So to summarize, any table will have two components, content and metadata. And if it is a managed table, Databricks will manage both. But for external table, so this is the external table. I know you're not seeing it right now. When we look into the delta format and delta lake concept later on in this video, I will show you how to create it, but you can just watch right now. So this table has its actual data in S3. Okay, so Amazon S3 has a bucket called CB company stocks and the actual storage location is in S3. Whereas for movies, the actual storage location is default storage, which means it's stored in Databricks itself. Okay, so for external table, data can be stored in S3 or any other external location, but metadata is inside Databricks. So for external table, once again, I'm repeating, metadata is inside Databricks, but actual data can be outside Databricks. When you have external table, multi-tool access is easy. So in the industry, you will see all these companies who will have this huge data lake in S3. So in that case, when they use Databricks, all they do is they use it as an external table so that metadata is still managed by Databricks. And then for managed tables, data governance is easy because Unity Catalog is a unique feature of Databricks. We will look into that a little later, but that controls everything. Whereas in external table, well, there is data governance because metadata is still inside Databricks, but it will require discipline. Let's say if you delete a table, it will delete the metadata, but it will not delete the actual content, which might be stored in S3 or any other location. So the use case, just in case if you're wondering when to use managed table versus external tables, when you're doing quick analytics and fully governed data, use managed table. But if you already have years of data stored external, either in ADLS or S3, then it's better to use external table, right? So the use case here is data shared with other tools or pre-existing data set. And when you have data in S3 or ADLS, you can access it from Databricks and you can access it from other tools also. That part becomes easier. We will now discuss Medallion architecture, and this is one of the popular questions that gets asked in data engineering interviews. This term sounds like a jargon, but concept-wise, it's a very, very simple concept. And the way they define Medallion architecture is it's a data design pattern used to logically organize data in a lake house. Now we have studied lake house before. Lake house is nothing but a combination of, so lake house is nothing but a combination of data lake plus data warehouse. data warehouse. When you combine these two, it makes a lake house. And when you're doing this transformation, you want to do this transformation incrementally and progressively to improve the structure and quality of data. So there are 3 layers: bronze, silver, and gold. Okay. Now this is the architecture. So let's say you are getting your raw data. So this is, let's say, your OLTP system. Okay. Let's say this system here, this entire system is your OLTP system, and you are getting some batch data and streaming data. And this raw data gets into your OLAP, and in your OLAP, let's say this entire block that you see, this gray block, is your data lake house. So it's a combination of data lake and data warehouse. You will have 3 layers. So bronze is very raw data. Whatever data you extracted from OLTP, you store it here. So that is raw. Then you do data cleaning, right? You filter null values. You will fix any typos. You will clean the data. So that is your silver layer. And gold layer is business level aggregate. So you generate, let's say, some new measures, etc. So let me just show you the example here. So I have this website analytics data, where if you look at any popular websites, they will be tracking their users' interactions with the website. So let's say user 001 visited this website homepage, especially on this day and time, and they spent 15 seconds. Then user 001 once again visited that website, and now they visited product page and spent 25 seconds, right? So this is just a general website analytics data. This is a raw data. You can see some null values, see empty values, some invalid timestamp. It's a very raw, messy data. This is what you will store in bronze layer. You see this bronze tab. Now, when you go to silver layer in Medallion architecture, you will do data cleaning. So maybe you will remove this row because it has a null value. You will also remove this row because it has invalid timestamp. And after doing data cleaning, see, these 2 rows you will delete. So you will have 3 rows left, and that is your silver layer. So in silver layer, you have done some data cleaning, some augmentation, you have furnished the data. Now this data is not fully ready for your analytics yet, because one of the KPI that you want to know is average time spent by any user on your website. So maybe for user 001, average time is 15 and 25. So 2 sessions, right? 2 sessions, they spend 40 seconds total. So average time spent is 20 seconds. So maybe in a gold layer, you want to have some kind of KPI like this. Okay. User ID, total visit is 2, average duration in seconds is 20, and so on, right? So this is Medallion architecture, folks. It's very simple, right? Bronze has all the raw, messy data. Silver has some clean data, and gold will have BI ready data. BI ready data means you would have created some additional measures, some additional KPIs. Since this concept was introduced by Databricks, this is a popular page, folks. I'm going to link this page and you can read through it. As I already explained, bronze is all raw data. Okay, you have load time, process ID, and so on. Silver is cleans and confirm data. Okay, you have removed your duplicates. You have your master customer stores, non-duplicated transactions, and cross-reference tables. And then gold is a curated business level tables. So the benefits of lakehouse architecture is simple data model. It's very simple, right? You have raw data in your bronze layer, clean data in your silver layer, and you have your business ready data in gold layer. When I was at Bloomberg, we used to have n number of layers, not just 3 layers. And we used to call it product 1, product 2, product 3. At every level, see, product 0 is raw data. It's not a product that you can sell to customers. But then product 1 is little bit clean. Product 2 is more clean. You're enriching at every stage and you are adding additional measures, additional KPIs. And based on the business needs, you can have this n number of layers. But when it comes to Medallion architecture specifically, they try to keep things simple. Okay, bronze, silver, and gold. And these are all the benefits. Okay, so just read through this article It's a very simple concept, and this is something that gets asked a lot during data engineering interviews. So I hope concept-wise, it's at least it's clear what exactly is Medallion architecture. As promised, now we will talk about Unity Catalog. Unity Catalog is a unified governance solution for data and AI assets on Databricks platform. Okay. Now, when I say data assets, I mean tables, views, etc. AI assets means models, etc. Right? You can have trained AI model which you have stored on Databricks, and this Unity Catalog provides governance. So governance means access control and how you want your data to be governed. You might have an organization where, let's say, there are two teams, right? So there is data analyst team, analyst, and data engineers. Okay. And there might be AI engineering team as well. Now, in Databricks, you will have your databases, your AI models, and so on. So let's say I'm in Databricks here. Okay. And let's say I have some database. Now, using Unity Catalog, you can give all the access. So let's say for data analyst group, you want to give only read access. Okay. And to data engineering group, you want to give write access. So you can give all of that. And these teams, they are called groups in Databricks. Okay. They're like role-based privileging. When you use role-based privileging, you have roles, right? So these are, let's say, roles. And then you can have users tied to it, okay? So let's say Tom, Peter, Mohan, these are all the users tied to this group. So when you give read access to a group or to a role, automatically these folks get that read access. And let's say you can have different type of users, right? Like different people, basically. These are the name of the people. And when you give write access, so these people will be able to write data to it. And then you can have trained AI models, right? So let's say I have these models and I have another group called AI engineer group. So this group will have write access and read access both, right? They train the model, etc. And then you can have another software developers group. Let's say these software developers are integrating these models into the rest of the ecosystem, then they are going to have a read access. In Databricks, you have 3 levels of hierarchy. At outer level, what you see is default catalog, right? This workspace is a default catalog, but you can create additional catalogs too. So I have created 2 catalogs, dev and prod. So you just go here, you say create a catalog, right? So you can have catalogs based on your environment, dev, prod, staging, etc. You can also have catalog names based on your 3 layers of Medallion architecture, bronze, gold, silver, etc. Or you can have it based on teams. So you can have one catalog for sales team, then you can have another catalog for, let's say, marketing team, etc. And within catalog, the second layer is your schema. So if you hover your mouse cursor over, you get schema, right? So it is always catalog, then you have schema, and then you have tables, volumes, views, and so on. All right. So just understand, Unity Catalog provides these 3 levels of naming convention. Now it is essentially a unified governance solution for data and AI assets. Okay. It provides centralized access control. So the access control is centralized. Previously, what used to happen is, let's say there is an organization, and by the way, I have worked in such organizations where there are databases which are owned by different teams, and there is different type of access control. So let's say team A is owning customer database, right? Let's say you have some customers data, and then team A has this customer table. Then team B also will have customer table. They will have duplications, and they will have different kind of access. So let's say this database can be accessed by 2 different groups, right? Like G1 and G2. But here the access control might be different. Here it might be G1 and G3. Let's say G2 doesn't have access control. So it's like teams are working in silos and they don't have unified governance. But with Unity Catalog, what you get it, right? So with Unity Catalog, what you get is centralized governance. So everything is in Databricks. Let's say all your data is in Databricks, And then you have catalog, right? So let's say you have catalog 1, catalog 2, and so on. Under that, you have schema, right? Schema 1, schema 2, and these will have tables. Now, even let's say if you have customers table, since data is in central place, you will make sure you are putting only one table here. Okay, so let's say either this or this table goes here. So let's say here I have customers table, and then through Unity Catalog I can give the access control to various groups. So if you go here and look at this catalog, right? So if you click on the catalog, see here you can provide the permissions. So you can say grant permissions to your users. And by the way, you can create users, etc. from here. So if you go to settings, identity and access and group, right? I have created a new group here. Let's say data analyst and data engineers. And then I can go to catalog and I can give that permission. So let's say in dev catalog, okay? Let's look at dev catalog now. In permissions, I can give all these permissions. So I can say, okay, data analyst. So data analyst folks have read access, let's say all the read access. See here you can control what kind of access you want to give. And then data engineers have write access and so on. Okay. So under catalog, then you have schema. Schema also have permissions. See, schema also have, you can just go to grant and you can give different kind of permissions. And then table also has permissions. Okay. So you can assign permissions at a fine grain level at different levels using this Unity Catalog. So it provides governance on tables and views, functions, AI models, notebooks, and dashboards. And this is the diagram I took from their GitHub. So essentially, see, when you look at your data, what is your data? You can have tables, right? Manage external views and so on. You can have objects, which is volumes, like your files, audio files, and so on. Or you can have models, right? ML models, vector databases. You can have functions, you know, like AWS Lambda type of functions. And then Unity Catalog provides unified governance on all this, you know, data that I have. It will provide governance on who can access what kind of privileges each of the groups or each of the individual users have, etc. And then Unity Catalog also provides Unity REST API. So let's say if you want to access it through AWS, Google Cloud, etc., then you can access it. Remember that Databricks is available, right, in different platforms, different cloud providers. So using all these tools, you can access Unity Catalog and access all these objects through a centralized governance. All right. So unified centralized governance is an obvious benefit of Unity Catalog. Then fine-grained access control. Remember catalog, schema, table, etc. Automated lineage and data discovery. By lineage, I mean this particular tab. So lineage means when you have any data, what kind of systems it has gone through. Okay. So let's say you have this particular table. Okay. So let me just show you here. So let's say you have some customers table. Okay. Or let's say you have some transaction table. Now that table is being updated by a set of system, let's say A, B, C, and D, right? So let's say this transaction table first, let's say someone makes a transaction on their mobile phone, and that mobile app is what is updating that table. And then it goes to downstream system. Let's say that system is B, which is further processing the system. Let's say it's doing some data cleaning. Then it goes through C. Let's say it's doing further adding new columns, right? So typically your data will go through multiple systems. And when you have something wrong in this table, you want to backtrack, okay? It's like you are a spy and you want to figure out what are all the places where data has traveled, okay? So it traveled from A to B to C, and that's how I got into this stage. So this is called data lineage, okay? Data lineage. And Unity Catalog by default provides that kind of feature. Right now, it's just a simple table, so you're not able to see much of the things here. But let me just look at the movies table. I think movies table will also not have anything interesting. Okay, at least here it is showing you who all updated that particular table. But anyways, it provides data lineage by default. And another thing it provides is or data discovery. So if you want to search through this data, there is this search thing, right? You can add the tags and everything. So if you have a movies table, let's say you want to add some tags so that your data is easily searchable, right? You can add all of that. And through the discovery feature, when you have a huge organization and when you're trying to locate the data, this Unity catalog will help you in that. Let's discuss another exotic topic called ACID: atomicity, consistency, isolation, and durability. And often during data engineering interviews, interviewer will touch base on this point. Let's say you are doing a transaction, you're transferring $100 from account A to account B. Now, internally, when you perform this transaction in a database, it will perform set of steps. It will read account A's balance, then subtract $100 from A. So let's say A has $500. It will first subtract it, right? So this becomes 400. And then it will add, let's say this account has 1200. So after transaction, it becomes 1300, right? Now let's say your computer crashes after step 2. At this step, computer crashes. So what will happen now? If you are doing this step by step, this will have 400 because it's subtracted, but it did not add $100 here. So where did $100 go? In the air? It is inconsistent, right? So either all these steps should succeed or they all should fail. So that is called atomicity. Atomicity means else all steps in a transaction should succeed together or they fail together. There shouldn't be partial completion. So if you work with MySQL databases, there is this begin transaction concept, right? So you begin a transaction, you update account A, then you update account B, and then you commit. So the entire block will get executed. So if something fails in between, it will roll back and it will undo all the partial steps. So this is called atomicity. Then there is a consistency. So let's say your account A has a balance of, let's say, $50. Now when you subtract $100, it will become negative. Unless you have overdraft rule, this is considered to be an invalid situation. Your account should not have a negative balance. And if you use again MySQL, you know that you can enforce this using constraint. So databases have this concept called constraint, where you can say that positive balance, see this positive balance, right? This check, it should be, balance should be greater than 0. So this balance column, it should be greater than 0. So consistency means transactions move the database from one valid state to another valid state, maintaining the defined rules and constraint. Okay, so that is called consistency. Then comes isolation. Let's say this account is a joint account between me and my wife. We have only $500, you know, we are very poor people. And let's say she transfers, you know, so let's say my wife transfers $400 from this account. And at the same time, let's say I'm in a different location and I am also, right, I am also transferring $400 to another account. Will this work? Ideally, it should not work, right? So if your database is following the principle of isolation, then this will not work, because when my wife initiates this transaction, right, and let's say if she commits it, then my transaction will fail. Okay, it's like you will have a lock, so both the transactions will not go successful. Okay, so that is called isolation. So concurrent transactions don't interfere with each other. Each transaction feels like it's running alone. Okay, then comes durability, which means once a transaction is committed, it stays committed even if the system crashes immediately after. So let's say you committed the transaction, and after it, even if the system crashes, it will stay committed. So it's called durability. So when you transfer $100 between accounts in ACID compliant database, okay, so this is called ACID principle in databases, and the databases who adhere to this principle is called ACID compliant database. So atomicity ensures both the debit and credit happen, or neither does. Consistency ensures that account balances stay valid and rules aren't broken. Okay, and isolation ensures other simultaneous transactions don't interfere, and durability ensures your transfer is permanent once confirmed. Alright, so that was a quick lecture on ACID. I hope you got a good understanding of this topic. Now I will take you to the movie Back to the Future and discuss this topic of time travel. Time travel is an essential topic in data engineering. Let's say Shivaji Investment is an investment firm. Now a regulatory body such as SEBI in India, in US it is SEC, FINRA. There are various government operated regulatory bodies that will monitor, your activity. So let's say Shivaji Investment is an investment firm. SEBI can come and say, hey, can you show me account balance of some customer as of Jan 2022, or whether certain trading restrictions were applied during a historical period. So they can do audit of the past. Okay, they can say, okay, this customer, how much money did they have as of this date, or what kind of data they saw. So it is as if they want you to do time travel in the past, and they want you to tell them what kind of screen did they see as of 2 years back, or what kind of status they had. So it's not just checking a balance, as if you're going back in time, and at that time what was customers experience. So there are a lot of rules. For example, in Europe there is GDPR. There are a lot of rules and regulations across the world where they have this requirement of time travel. Basically they want you to maintain version history, as if you are doing git commit. If you use git, how you commit. So they want you to have that kind of versioning for your database. Now we can do versioning of a database in couple of ways. The first one is copy on write. So let's say you have this record. As of October 6, 2010, the record looks something like this. Now, if you're doing copy on write, when someone updates address, let's say this person moved to Paris, right, from Delhi, what will happen is it will not update this particular record. It will insert a new record along with that new information. Okay, let's say then balance got updated. So now you are inserting new records. You are not overwriting that field in that particular record. This is called copy on write. I understand due to this your data storage will increase, but nowadays data storage is actually very cheap, and there are solutions in the world of databases which will provide you this kind of version history at a very low cost. Then the second way of maintaining version history is transaction logs. So instead of inserting a new record, you will only record what got updated. So your log as of October 29, 7 a.m. will be, okay, my address updated to this. Okay, then okay, my balance updated to this. Now if someone wants a record, right, someone wants this particular record as of this, what you can do is you can replay all this. So you take this base record and you replay all these transactions, and then that way you can get this entire record. Okay, as I said, this is similar to Git, where in Git you see this version history. Whenever you're writing code, your code file will have version history. So it is a very similar concept. There are a lot of benefits, folks. First one is audit and compliance. It is absolutely needed. When I was at Bloomberg, we had our own data store, and we used to do the same thing because Bloomberg is a finance company and they had this kind of audit requirements. Error recovery. Let's say you update some transaction, and let's say you figure out that there is an error and I want to roll back to a state 4 days ago. You can do that just like Git. You know how you do Git revert. If your code changes have a problem, you will do a revert to a previous commit or a commit 10 commit before, whatever. So that kind of error recovery you can get in the case of databases as well. And you can do historical analysis. Now in Spark, there is this delta format. And when you are using delta lake or delta format for a table, then you can do this kind of versioning. So all the tables that we have seen, right, the managed tables like movies, etc., those are in delta format. So see, if I am on movies and if I see data source, it is saying it is delta. So we are going to talk about delta in a bit, but due to delta format in Spark, you can get this kind of version. So, okay, select star from table, version as of 5. Or you can query using timestamp, select star from table, timestamp as of this. So this way you can get, just like Git, you can get a record in the history, okay, or restore table to version as of 10.
In the next two sections, which is AWS Account Setup and Data Lake and Data Format, you will learn about external tables using S3. Now in our end-to-end project, we are not going to use any external table. So it is completely okay if you skip next two sections. But if you want to strengthen your knowledge on this concept, then please go ahead.
Folks, we will be using AWS in the upcoming chapters. So let's first set up the account. You can Google create AWS account and click on this link. Here, click on create a free account link. If you already have an account, then you can skip this video. You can log into your account. But if you don't, then sign up for AWS and here provide your email address. Okay. And then you can provide some AWS account name. I'm going to say Code Basics Double, whatever. Account name doesn't matter that much, but here you can provide your Gmail ID. Once you do that, it will send an email to your email ID to verify. So I have done the verification and now I can provide my password. So just provide a password and proceed further. Okay, at some point it will ask you for selecting your plan. So I'm going to say, okay, free 6-month plan. Okay, so let's select that. And you can provide all the details here. So see, in the previous screen, it asked me for my credit card. It is not going to charge. Actually, they just do this credit card verification. So you will get some free credits. Okay, so you can provide your credit card details, etc. And then it will ask you for this SMS just for another verification. So here is send a code on my phone. So I'm just confirming my identity. So it will require multiple step of verification. Okay, so now see, my AWS account is set up. At any step, if you're feeling stuck, folks, use common sense. You have to use common sense. Take help of ChatGPT. Setting up an AWS account should not be a rocket science. You should be able to figure it out, folks. Okay, so please do that. And now I can go to AWS console where I'll be able to kind of see different offerings and different options that AWS has. Folks, in this lecture, we will learn another important topic called data lake or data format. For this, I need to set up another S3 bucket. So let me show you that first, and then I will explain step by step. So here I'm in Amazon S3. You can use any S3 account and just create a bucket. And the bucket name has to be globally unique. Okay, so I'm going to just say CB company stocks 001. Okay, now I'm going to use a sample company stocks file, which I'm going to share with you so that you can use the same file. Okay, so see, these are the columns I have, and I have some simple stocks data. So let me upload that data. Okay, so here, this is the bucket name, and then everything else is default, and you will create this particular bucket. Okay, so now let me go to this stock. By the way, you won't be able to use this name, so you can say CB company stocks 002, 3, whatever, or just give your name initial. Okay, make it unique. So here I'm going to upload a file. So drag and drop. I'm going to give you this CSV file. Okay, so just drag and drop that particular file and just say upload. So my S3 bucket is set up now. The next step is to set up an external location. So go to catalog, external data, create external location, AWS quick start, and here type in this bucket, right? CB company stocks, whatever. So I will say S3. This is the bucket, generate a new token, copy, launch in quick start. This is just doing the connection. Okay, so here let's see. Yes, this is the token. So I'm copy pasting the token. Everything else is same. I acknowledge. I never say no to this kind of thing. Okay, and now I think it has established that connection. So let's go back to Databricks. After you're done it will check back for your new location. Okay, so just say external location. It took some time, but eventually you will see create complete here. And then when you go to external data, you will see this particular location, right? S3 CB company stocks. Now you can go to your SQL editor. So click on that and you can run this command, select star from csv.this header equal to true, and you will be able to see the entire table. Okay. Now let's create something called a delta table. Okay. So this delta format is actually a storage layer on top of your data lake. So let's say my data lake is in S3. Okay. So in S3, this bucket, I have one CSV file, but let's say you have a bunch of CSV files or Parquet files. And this is my data lake, let's assume. So what delta format will give you is it will give you storage layer on top of it. Because see, here the data is scattered, right? There is no versioning. You cannot do time travel. There is no ACID properties. Someone can overwrite this file, right? This is like a folder on the cloud. Anything can happen here. So this delta format or delta lake provides ACID properties. It provides this kind of time travel, version control, version history, and so on. So I'm going to create a delta table. So see, create table this using delta, and this is the format. So now in location, what I'm saying is here, this is my bucket. And then what it will do is, see, I'm having this bronze, or let's say I can just call it delta. Okay. So this is a delta folder as this. So now see, when I do select star, it will select all the columns. On top of that, I am having these 3 additional columns. So basically I want to use the same schema as whatever I have in this CSV file. On top of that, I want to add these 3 columns. So first one is ingested at, so when did I create this table? Input file name and the UUID. Okay, UUID as bronze ID. So usually when you ingest the data into Delta Lake, under Medallion architecture, you will have bronze layer, then you have silver, and then you have gold. Okay, so you can call this bronze also. Okay, so let's say I'll just call it bronze. So I hope you're getting it, right? So when you do, so let me run this query separately. So when you do this new query, so input file is not supported, I understand. So will not be able to run it, but I hope you're getting the point. And then when you say using delta, see, it will go to this particular location. It will get all these records and whatever records we have in this file, and it will create that table. So let me run it so that you get an idea. So I'm just simply running this particular command. Okay, so it ran that command, and now I'll go to catalog and workspace, default, tables, company stocks. See, I get this table, company stocks. So sample data, hooray, I got all this data. And then if you look at details, it is actually an external table. Okay, this is external table, and I have this particular history. Okay, so this is an external table, and I have all this history. So I'm going to now modify some records. Okay, so in the version history, you will see more records. So let me just modify some record here. So here, and I will say update company stock. Okay, set. Okay, what do I want to set? So I want to set, let's say, stock price, stock underscore price. So set stock underscore price is equal to, let's say, 70. Okay, so this is, okay, so this 62.67, I want to set it as a 70. And where company is equal to, what is company? Apple, right? So company is Apple. So let's run this command. And now see, it will update the delta table. It will not update the actual CSV file, okay? So if you go here and, okay, let me just do sample data. So now when I run this query, select star from workspace, whatever, where company is equal to Apple, you see the price I'm getting is now 70. But when you look at the history of this particular thing, you see now you're getting a history. So as of this date, now you are having this record, okay? Now same thing if you want to get the version as of this, right? So if you want to get 0 version where Apple stock price was, I think 67 point something, then you can say version as of 0. I think you have to move version as of 0 before the where clause. So let me run it. So now when I do it, see 62.67. And if you do version 1 and run it, you get 70. So that's the beauty of this delta format, that you can have a version history. You can have a time travel. You also have all the ACID properties that we discussed. So see, when I updated that, the company stocks.csv file is not changed, but it created this bronze. You see this bronze, and in bronze, I have this delta log. So I have the data stored as Parquet. You see this Parquet, and you have like different versions, and you have this delta log. To define it formally, Delta Lake is an open source storage layer that brings ACID transactions, time travel, schema enforcement to your data lake. So basically, Delta Lake solves issues with data lake. You have your raw files in your data lake, right? So let's say this is your data lake. So I have my data lake, which will have my raw files, right? Let's say my CSV files, Parquet files, whatever. And the issues that I have here is, first of all, no audit trail, right? No audit trail because I don't have versioning. Then concurrent rewrites, right? So that can cause data corruption. If I'm on a S3 bucket, someone can write my CSV file easily. There is no schema enforcement, right? No schema enforcement. So these are all the issues with data lake. So what people do is they use Delta Lake, which is just a layer on top of your data lake. See, your data lake, you're not replacing. Your data lake will remain, but you hook your Databricks like how we did it, right? You hook your Databricks with this, and from CSV file, you saw from CSV file, which was customers, we created a delta table. So from this CSV file, let's say you create delta table from Parquet file, whatever. You create these delta tables and it will solve all these issues because delta tables have version history. So it solves this problem. They are ACID compliant. So it solves data corruption. They are just like relational database. So they will solve the issues with schema related issues as well. Okay. So they will prevent the data corruption. Okay. So it's an open source storage layer that brings all these benefits. And it is built on top of Parquet files and adds a transaction log to track all the changes. In short, Delta Lake is equal to Parquet files, transaction logs plus metadata. And what problems does it solve? All these three. And we already saw the transaction log is stored in something like this, where you have your actual Parquet files, right? So your data is stored in form of Parquet files. And you have these transaction logs, right? We've initially discussed about transaction logs. So in the log, just like Git log, you will say, okay, this field updated, that field updated. And this is what we saw, right? Like when this bronze was created, see, this is a delta log. So these are actual Parquet files. See, this is Parquet, this is Parquet. And when you go to these logs, you will see the actual log file. So the typical architecture that people use is, let's say, they have their data lake, which has CSV files, Parquet, CSV, Parquet, relational table, and so on. And in Databricks, what they do is they set up a catalog and they have this raw location. So raw will be an external location. So it will be pointing to that. Then from raw, they create this bronze layer. Okay. And this bronze is in delta format. So it gets all this benefit. Then they have silver. This is also delta. Okay. So here they do transformations, data cleaning, and so on. And they get BI ready columns, aggregation, and new columns in gold layer. This is also delta. Okay. So this is the typical architecture that people follow. And in our Spark project, we are going to use the same architecture. Okay. So raw is just pointing to this location. And then you have bronze, silver, gold, which are in delta format. Okay. So this is essentially your data lake, and it is a core component of your data lakehouse. Remember, lakehouse is a combination of data lake and data warehouse, and delta lake or delta format is a core component of this lakehouse architecture.
We will now begin the work on the project. Please check the video description. We have provided all the useful resources along with the code. We have also included a summary document. So please do a quick recap before we dive into the project. We will start by discussing the technical architecture of the project. Here is a diagram of a legacy architecture. We have an OLTP system here where there is a company's application server, and you have a relational database that stores all your transactional data. Okay. Now, just in case if you don't know OLTP, OLAP, ETL, etc., then you can refer to this video. I have explained those concepts by going over data warehouse, data lake, and data lakehouse. And the second component in the legacy system is once you have all your transactional data in your OLTP system, you will do a data pull using some Python script and store that into S3, which is your data lake essentially. Okay, so here S3 is an object store, which is your data lake. And then you are using variety of AWS services like Lambda, Glue, EC2 for doing your ETL, compute, and data processing. And then you store your data in your data warehouse. So here you are using Amazon Redshift as your data warehouse. And you are then plugging your BI tool, either Power BI, Tableau, whatever tool you're using, to Redshift for doing your BI reports. Now, while this technical architecture is functional, it has a couple of issues. The first issue is you have fragmented ETL and maintenance overhead. You are using so many different AWS services. Your ETL logic is scattered throughout, all these different pieces, and you have this AWS billing system, right? You don't have much transparency on how you are being billed. The logic is fragmented, and you have to do a lot of maintenance, right? Setting up things in AWS might not be easy, especially if you're a beginner. There is a learning curve. So that is the first disadvantage. The second issue is limited scalability and cost inefficiency. The cost of AWS can easily go high with this kind of architecture, and we are not using any native Spark cloud platform. Therefore, there is limited scalability, and there is lack of unified platform as well. Now, Databricks solves all these problems. So we are going to have this new architecture where we will do data pull using Python, store it in S3, and then after, everything will happen in Databricks. So Databricks here is a single unified platform where you will do your data analytics, data engineering. Even if you want to do AI, you can do all of it in this single platform. And even the BI report and the analytics that we are going to generate is also part of the same Databricks platform. Okay, so Databricks will solve all those three issues, and we will work with this new architecture. One thing I want to point out about new architecture is that this is based on data lakehouse architecture. So previously you had separate data warehouse, data lake, etc. Here, although we are using S3 to store our objects, we are using S3 along with Databricks, and then we are doing everything like data analytics, data engineering,
in the future if you want to do AI, everything on a single platform. Also, we are using the Delta format of Databricks. Okay, therefore this is a data lake house architecture. All right, now I'm in my Databricks login, and we have looked at Databricks platform and learned the foundations in the foundation sections. And here in the project, we are going to begin by creating the catalog. Okay, so let's go to catalog here, and by default you see workspace and system, and you can click plus and create a catalog, or you can do it by code. So we are going to do it by code. So let's go to workspace and create a new folder here. If you want to attach it to Git, you can create a Git folder and link it to your Git repository. So create a folder, and new folder name will be, let's say, project e-commerce. You can give it whatever project name you want to give. And this will have another folder called setup. So all our setup code we will store here. And let's create a new notebook where we will attach it to a serverless compute. Okay, so while this is attaching, let's write our code. We all know that if you want to run SQL query, you will write %SQL, and then you can run this command, create catalog if not exist e-commerce. Okay, control enter, and this will create that catalog. So while this is running, I will open this catalog in the new tab, and then whenever it comes up, I will show you. So if you go here, see, now we have this new catalog. Now from the foundation section, you know the difference between catalog, schema, and tables. So it's just 3-level hierarchy, folks. Okay, so here you have catalog, then you will have schema, and then you will have tables. Okay, so let's now do another thing, which is %SQL and use catalog e-commerce. So whatever code you run after this line, that code will use this e-commerce catalog as a default. So we are going to now create 3 schemas. We are using Medallion architecture, folks. So we will create bronze schema, silver, and gold schema. Okay, let's hit Control Enter, and this says okay. If you refresh it here, and you will see bronze, gold, and silver schemas. You can run this command, show databases from e-commerce, and whatever structure you are seeing here, you will see the same structure here as well. See, bronze, gold, and silver. While running the code, let's say due to whatever reason you made a mistake and you want to drop the catalog, then you can just say drop catalog, this cascade, and cascade will delete everything underneath e-commerce as well. All right, so our catalog setup is done. After the catalog setup, let's work on uploading the data. See, if you're working for any company, the way it will work is it will pull the data from OLTP system via Python into S3. Now, since this is a learning project, we are not going to cover this OLTP part, right? We are mainly interested in data engineering. So we will have a bunch of CSV files, which we will directly ingest into Databricks. Okay, so we will start from this point, and I'm going to provide you all those CSV files in this folder. So once you look at video description and download that information, you will see this folder, which will have different subfolders. So here my fact table is order items, and remaining tables are my dimension tables. So if you look at brands has this CSV file, which looks something like this. So you have brand code, brand name, and category code. Okay, so we will identify these brand codes with this unique category code, CE, app, etc. Then you have categories. For example, for electronics, you will use this code CE. For home and kitchen, you will use HNK. Then you have products. So remember HNK is home and kitchen. So that's how you refer to this code in your products table. Okay, so you have product ID, SKU, color, size, material. You can look into this data. It also has this brand code. Okay, so category and brand will point to those two other tables which we just looked at. Then you have customers table, pretty straightforward, customer ID, phone, country, state, etc. And date dimension table has date, year, quarter, etc. Let's say in our BI dashboard, if you want to do analytics based on quarter, okay, what was my revenue in
Q3, Q4, etc., then having this kind of dimension table will be helpful. And finally, we have our fact table, which is orders. Okay, so it will have date, order, timestamp, customer ID, how much quantity you order, right? The price, because this company has stores in multiple countries. So, Great Britain's INR, Australian dollar, and so on, unit price, discount amount, the coupon code, and so on. Now, if you check order items table, it will have this landing subfolder which has files specific to a date. What we saw is a file for just one day, but for every day you will get a separate CSV file. And we have 3 months data, okay, for the month of 8, 9, and 10. See, 10/31. All right, now all of this data we will now ingest into Databricks. So if you go to catalogs here, and if you click on your e-commerce catalog and click on create schema. Now schema is something we can create here through code as well, but we are going to just, I will show you the manual way of doing it. We will call this source data. Now here you can use external location. So let's say if you have data stored in some outside place, you can point it to that place, but we are going to use a managed location here. So just say create schema, click on create, and now you see source data here. So just click on this, create volume. In this volume, we will call it raw. Okay. And this is going to be a managed volume, which means the data files are stored in location managed by Unity catalog. Okay. So let's hit create button and then click on upload to this volume. So now I will go to my folder and I will click on all these subfolders, okay, so and drag and drop them here. So it is creating this volume. See, volume / e-commerce / source data / row, hit upload button. All right, so see, my source data is ready. I have raw, under raw I have all these subfolders, and when you go to like any subfolder, you will see the files as well. Now you may be wondering, why do we need raw? Can't we directly store it in bronze? This raw volume is kind of our dump ground. We just dump data as is without any changes. Whereas in bronze, we might make minor update. It is still raw data, but see, it is in Delta Lake format. Okay, so it gets all this ACID transactions, time travel properties, etc. Therefore, it is a common practice to have raw as a dump ground and bronze as a place where you have structured raw data. From raw, now we will transfer data to bronze and we will begin with the dimension tables. So let's go to workspace here and under project e-commerce, let's create a folder. We will call it Medallion Processing Dim. Under that, let's create a new notebook. I will name it 1 dim bronze. In this notebook, what we will do is whatever dimension data we have, we will create a table in bronze layer and we will ingest that data. So let's import some necessary Python functions first. Then the catalog name is e-commerce and we will define the schema for our brand dimension table. We already saw brand table has brand code, name, and category code. These three, see, they all are strings. So they are all string type. Let's execute this. Now see, you don't see any table under bronze. So our goal is to create those tables. And also in source, we have data at this path. Okay, so let's copy this particular path and we'll create a variable called raw data path using that path. And in that, whatever CSV you have, you will use it for brands. Then create a data frame using this. And the way you do it is you specify raw data path in this parameter. The schema is that schema, right? It is comma separated file. So that's why you're specifying this parameter and header equal to true, which means that this particular file has this header. Okay. So let's create a data frame, and in that data frame, we will add the metadata columns, right? So metadata columns are the source file, ingested it. So whenever there is a problem, you want to do any audit, these columns will be useful. So let's create this data frame and see how it looks. All right. Our data frame looks good. See, these are the 3 main columns. These are the 2 metadata columns. So the idea here is you load data from CSV into the Spark data frame. And then from Spark data frame, you will write to a table in Databricks. Okay. And that's a delta table. So you will say df.write format is delta. and you will say mode override. Let's say if there is an existing table, you want to override it. Merge schema is true. So let's say tomorrow if you get 2 new columns, then it will merge those columns. Okay, this is for schema evolution, and you will call your table brz_brand. So let's execute this. This is done. And now let me go here, refresh, and under bronze, now I see BRZ brands. And if you look at the sample data, you have to select a compute, of course. So start and close. See, my table is created successfully. Now you will repeat the same process for other dimension tables. So I'm not going to write that code because it will take too long, but it is essentially the same logic. Okay, you go to your category dimension table, your products, and so on. See, for category you define the schema, exactly same process. Your raw data part, see, category star.csv, and then you do df.write to brz category. You will do that same to brz products, customers, then date. Now in date you might be like, okay, why date is a string type? Well, we want to store the data in a same format as a string, and when we do silver processing, at that time we will create the date data type. Let's go ahead and create a new notebook for the silver processing, and I will call it dim silver. Here, as usual, I will import some useful functions, and then we will create a data frame called df bronze with spark.table. Let's use the Python format string here to say catalog name dot bronze is the schema, and then brz dot brands is the table name, and then df bronze dot show. So see, this is my bronze table. Now immediately I notice some issues. For example, there is an extra space after brand name. So why don't we remove the leading and trailing spaces from the brand name? So here you will say df bronze, and the function that you use is with column. Okay, brand name is the name of the column, and you will use f dot trim. Okay, so you are going to trim this from the brand name function. So f dot column brand name, and let's assign that to a new data frame called silver, because silver is the clean data frame. Okay, so show 10, and now see, you have space here in after Nova Wave, but here that space is gone. The other issue I observe is these brand codes have this extra character. Now when I talked to my business manager, he said that the brand code should have only alphanumeric characters. Okay, and if you want to detect only those characters, you can use regular expression. So if you go to regularexpression101.com website, you can test your regular expression. So here this expression says that include the characters which are between capital A to Z, small a to Z, or 0 to 9. But if there is any other character, so this is a negation. Okay, this sign is a negation sign, and that will say that detect those characters, and when you detect those, you can replace them with space. So you can do all of that with this code. You will say in brand code, if you have any character which is not alphanumeric, replace. See here, you're using regex replace function, replace those characters with space. So it will replace it with this particular space. Okay, so let's execute this, and now you notice that volt, right, there was this character, so that particular character is gone. Now it's a common practice that you will try to identify all the unique category codes, brand codes, and so on. So let's do that. So I will run this distinct function on the category code, and when I do that, I find that there are some discrepancies. See, books and BKS, then you have toy and toys, grocery and GRCY. So once again, you can talk to domain experts, your business managers, and they can say that, okay, these are same, so let's replace books with BKS code, grocery with this code, and so on. All right, so these are the anomalies that you found, and you would like to replace these with the actual code. The way you do that is you will say df silver dot replace. So there is a replace function, a replace that you can use, and here
anomalies, and then there is a subset, right? So subset is category code, and you can say show. Now instead of seeing the whole data frame, I will just say this, okay? And you can assign this back to df silver. So when you run this, okay, I think I should not have this show here. That's why I was getting that error. All right, now you see, you don't see this books, this grocery and so on. You have just the valid unique codes. Once that is done, you will write to a table. So you'll write to a SLV branch table, okay? And when you go to your silver schema and refresh it, you will see that particular table. Now I have done data cleaning for other tables too. I'm not going to write each and every code in front of you because this is not an EDA tutorial. This is the Databricks tutorial. So let me just quickly go over it. I'm going to provide you all this notebook so you will have all the code, okay? So now for the category table, we will do some other type of data cleaning. So first, we will find out the duplicates based on the category code. For example, app category code has 2 count, grocery has 2 count. You see, app has this record and this, grocery has this, and these are clearly duplicates, okay? So you can just simply drop them by calling this drop duplicates. So whenever you have Spark data frame and you say drop duplicates and provide a column, so on that column, it will, whatever is the duplicate, it will just drop it. And then when you display it, see, those duplicates are gone here. The other thing you will do is you will convert category code into uppercase. So right now it's small case here. When you do f.upper function, see, it has converted this entire column into uppercase. All right, what's next is writing that table to SLV category. So you'll do that. Make sure you are running all this code on your computer. Then for products table, you will find out the raw and column count. Okay, so you have 50,000 products, folks, with 14 columns. Okay, so we got that into this DF bronze data frame. This is how the product table looks with the metadata columns. Okay, and when you look at the weight in grams, see, you have all this, right? G. So you can remove this G character and convert this into a double column. So here, see all these G's you have, you will just say G, replace that with string, and then weight, you can use integer type. Okay, so fine, integer double. So you cast it to the numeric type, and then when you look at it, see, that G is gone and it is looking good. Same thing you will do for length column. So for length, you have this comma. So you will replace that comma with dot by just saying, okay, replace comma with dot, regex replace, and then casting it to a float type. Okay, so this is your length column now. Then category and brand code are in lowercase, so we need to make it upper. Okay, so in the products table, basically they are lowercase, so you will make it upper by calling this. So you can do cascading with column. You can call it in a cascading fashion. And then for material columns, you have some distinct categories. Okay, cotton, steel, wood, all of this. And there are spelling mistakes like cotton. See, the spelling is wrong. So it should be cotton, double T. Aluminum should be this, rubber should be this. So you will just use this f.when function. Folks, I know I'm going in fast, but if I do each and every transformation, this course is going to be like 10 hours. For EDA, I have some other videos too. So you can do so many things when it comes to data cleaning. Okay, so I'm just showing you few of those things. So please look at the code. Once again, check video description. All the code is provided. Then for rating count, you see it's negative. Rating count should be a positive number. So you will make it positive by calling this f.abs function. Okay, so on this column, make it absolute. Otherwise, f.lit is 0. If it is null, then a rating count is 0. All right. Then check the final clean data. So your products table looks pretty good now. And then write that to SLV underscore products. So by calling this method, we are creating a new table. I mean, the table schema is created, but we are filling the data, okay, for this table into your silver schema. The table is in bronze. Now we are creating a table in a silver schema. And you will do a bunch of transformation for your customer. For example, customer ID column is null, and you have some 300 null records. So what you will do is you will just filter it, right? Or you will just display first. Okay, let's display and see what's going on. Okay, so these are the columns having customer ID as null, and then you will drop them. Now, how do you handle null depends on situation, your business logic. If you have too many records with null values, maybe you want to replace null values with some valid values. But here 300, and again, while discussing with business manager, they're like, okay, it's okay to drop that data. So you dropped it. Same way, number of nulls in phone. Okay, this many, and these are the numbers. For that, you don't want to drop it because not having phone number is okay. Some customers do not provide phone number. So there, instead of having null, you will say not available. Okay. So you will say in phone, it is not available. And then you write that to silver customers table. And the last one is our calendar table. Now in calendar table, if you look at the schema, see date is a string. You want to convert it to a proper date type. So you will first format it in DDMM format. Okay. And you convert that to date by calling this to_date function. Now, when you check the data type, see date has a date, proper date data type. You will also remove duplicates. Okay. So see, for certain dates, you have higher than one count. So in our date table, there should be only one record for a given date, but for 29 date, there are 2 records. So you will use our usual drop duplicates function. Okay. And then you will normalize the day names. So if you look at our day names, see, there is no consistency. One is small case, one is entire uppercase. So you want to normalize in a way that the first letter should be capitalized. See, capitalize first letter in day name. So see, now it looks consistent. And then convert negative week of the year to positive. So some of the, I think, see, all this week of the year are negative. They should be positive. So once again, you call f.abs function to convert them to positive, and then enhance quarter and week of the year column. So for week of the year, you are saying week 31, 2025. See, here is just 31, right? And also quarter is just 3. So instead of 3, you will say Q3, 2025. Q3. So this is useful. So you're using all these functions. Please take a look to make those enhancements. And then week of the year, you will rename it to week. Okay. And then you will write that to this silver schema. So now when you go and refresh your tables and go to silver, see, you will see all these wonderful tables. And you can just do some spot check by looking at the sample data. So this is how it looks. Let's check our calendar table, go to sample data, and see, here you see clean enhanced data. See, quarter is Q3 2025, week is this, day names are normalized, and then you have some duplicates which are removed as well. Let's now work on gold layer. I have created this 3_d_gold notebook, and we will be creating business ready columns in our tables. So if you look at our products table, it has category code, brand code, etc. But when we plot our BI dashboard, we will have descriptive names. So instead of H&K, we will have home and kitchen and so on. So what if in gold layer, we have just one table, products table, and we can get rid of this category and brand table, and we can put that descriptive name here. So just imagine you have gold products table where you have category code, and for H&K, you have category name, which is home and kitchen. Same way for brand code, you have brand code and brand name, right? So that way we can get rid of this brands and category tables in our gold layer. Okay. So here we are just loading all these 3 tables into Spark data frame. And then if you want to pull the category code from the category table, right? So H&K, if you look at the silver category and go to sample data, H&K is home and kitchen. So you have to do a join using this H&K. Okay. And for doing join, views are useful. So what I have done here is I have created 3 temporary views.
So the purpose of view is that your data frame will become more like a table, okay? And then on these views, you can just run all these queries. So when you say select star from V products, limit 5, see it shows this. Select star from V category, whatever, limit 5, it shows this. And then brands will show it. I mean, this way you will understand views better. And then we are using this e-commerce catalog. Now look at this query. What you're doing here is you are creating a new table called gold dim products in gold layer. And the way you do that is first you join brand and category table, right? How do you join brand and category table? So check this. Category has category name and category code. But if you look at brands and if you go to sample data, brand has brand name and brand code, but it also has category code. So if you join it, you get single table which has brand code, brand name, category code, category name. Okay. And that is something you can do with this query. So this is CTE and you are saying that give me brands and category table which has those 4 columns. Which 4 columns? Brand name, brand code, category name, category code. Once you get that, you feel like you have got this one table with those 4 columns. Now you run this another query, okay, where see this brand category is BC, and you will do a join between that and products table using brand code. So it's a simple left join between product table and this new 4 column table that we created. You're doing a join and we are selecting bunch of columns. Okay, so let's execute this, and in gold now you have GLD dim products table, and see this is what we got now. So along with category code you have category name, brand code you have brand name. Then for customers table it will be useful to have region. Okay, so see our customer table in our silver schema, if you look at it, let me just show you here, it has the state. So let's say for country India, it has states, MH is Maharashtra, then TN is Tamil Nadu. But in BI dashboard, our business managers wants region level analytics. They are like, okay, what were my revenues in my west region, east regions? And we don't have that in customers table. So how about we map all these states with regions? So Maharashtra, Gujarat will be west region, Assam will be east region. Okay, so you can get this kind of mapping from business. So see, in south you have Karnataka, Tamil Nadu, AP, Kerala, these are all souths. Then you have west, you have north, and so on. So you can get this kind of mapping from domain expert, from your business managers, for not just India country but all other countries, right? Australia, UK. So it's a simple dictionary. Okay, so our country state map dictionary is a nested dictionary, and if you execute this you will get this kind of dictionary. See, for India you have state and the region, for Australia you have the state and the region, and so on. And then you can create a flat list basically. So flat list is like bunch of rows. Every row has country, state, region, these 3 columns. Okay, and then you can create a data frame, and this DF region mapping data frame is created based on those flat rows. See, it has country, state, and region, and then you can do a join. Okay, so now we are going to create a silver table first, and silver customer table. See, this doesn't have region, but now when you do a join with region mapping table on country and state, and for any state, if you don't have a region, you will say other region. So let's execute this, and now see, here you are getting India, Maharashtra is a state, and then customer ID. These columns are not in a right order, but let's look at the data, at least let's verify the accuracy. So India, Maharashtra, country code is IN, and see, look at this. This is amazing, right? The region is west, and you have customer ID, phone, country code, and so on. Okay, so you can write that to your customers table. Now see, gold has only dim products tables, but when you refresh, it is refreshing right now, you got this customers table. And if you look at the sample data, see, your customer ID, phone, country code is this, state is this, and then
you have these regions. Now let's look at the date table. So here we are going to download SLV calendar, not download, but create a data frame out of your silver calendar table. And then we will create a bunch of new columns. For example, is weekend. Okay. For this date, let's say you want to know whether it's a weekend 1 and 0. In BI dashboard, imagine you have a filter. Okay. What are my revenues on weekend? What are my revenues on weekdays? So this column will help you do that. Correct. So the entire purpose of gold layer is to create columns which will help you in your analytics. So is weekend is one column. The second one we created is date ID. See, date ID is nothing but you take a date, remove the hyphens. See, if you remove the hyphens, what do you get? See, this is the date ID 2025-0907. Then you get month name, because in BI dashboard, imagine you have filter. Okay, what are my revenues in January, February? You might have seasons, right? In summer months, there might be revenue decline or revenue increase. In winter months, in fall season. So for all those, month name might be useful. Okay, so we created these three columns: date ID, month name, and is weekend. These three columns that you see at the end. And then you might want to reorder certain columns. So you can say desired column order. Then you say .select goal, and see, now you have all these columns. You can, by the way, rename that for customers table too. Okay. All right, let's write it to gold dim table. And when I go here, I see dim date and sample data. And here I see this, see, is weekend. This is a new column. Then the month name is another column, and date ID is the another column that we generated. All right. So our gold layer now has three tables, and these three tables contains additional columns which will help us in our BI dashboarding. We will move on to the next step, which is processing the fact table. So here I'm going to create a folder called Medallion Processing Fact. And in this folder, I'm going to import some notebooks, right? These three notebooks, I will just drag and drop here, and we'll go over these three one by one. So let's look at first the bronze notebook. Okay. So here we want to take the data from our volume. So if you look at the data here, let's say our source data volume has raw folder, then it has order items, landing, and this is the place where we have our CSV files. So we are going to copy this, and from this volume we will take all these CSV files and create a table inside our bronze, which will say bronze orders. Okay, so let's import some necessary libraries. Then catalog name is e-commerce, and here is the schema of our orders. And right now we have mentioned everything as string because there is some data quality issues, and to tackle that we need to have everything in string. So let's create the order schema, and then this is that same path. See, we have taken that same path here and all the CSV files in that particular path and created a data frame. So this data frame is created from this raw data path you see here. Then you have delimiter as comma, header equal to true, and two metadata columns. So let's execute this, and then let's display the data frame. So see, my data frame looks good. It has around 183,000 records from all those CSV files. See, we have many CSV files, 3 months data. So the total records in 3 months data is 183,000. And then we will write that to bronze order items table. So when you say df write.format, it will write it in delta format due to this argument. And once this is done, you can go here and you can go to gold, not gold actually, but bronze, and you will see this order items table. And if you look at some sample data, then here are my records. Now, when you look at this particular table, so let me just pull it from CSV file because bronze and CSV is same. It's raw data. I clearly notice some data quality issues. So in the quantity column, right? So let's look at this order, right? So this is one order where the product ID is this, quantity is this, right? The currency is this. But in the quantity column, you see some quantities are in text, some quantities are in numbers. So you want to convert all these two to actual number 2. Then for unit price column, you see this dollar symbol here, dollar symbol, dollar, there is extra space. So you want to convert that to a number. The next thing you want to do is you want to remove this percentage column and get like something like for 10% you want to get 0.1, because eventually after your silver processing you want to have new columns. For example, let me insert a new column here. You want to have a column such as gross amount, right? So the gross amount will be equal to quantity. So let's say this is the quantity into the unit price. I mean, here is just one quantity, but for example, here, if you look at it, right, quantity into the unit price, and of course, this is not a percentage column, so you can convert that to a number or go to format cells and you want to have it as regular. So you want to have gross amount, which is multiplication of these two. Then you want to know the discount amount, right? So let's say, what will be your discount amount? Well, discount will be this number into this, right? So now this is in percentage. So you have to internally, like you have to convert it to a number, but here is showing the right number. So on $11 gross amount, you got the discount as 1.11. And then you want to have sales amount, right? So sales amount will be how much? Well, it's very simple logic, folks, right? It's a gross amount minus you subtract the discount. So this is the amount that customer is paying. So you want to generate these kind of columns when you do your gold processing. Also, based on the suggestion from our business manager, we will convert this channel name to the full name. So web means this sales was generated through website. So maybe we'll convert this to a complete descriptive name. App means this sales was generated through mobile app. Customer went to the mobile app and ordered it. Okay. So we'll do all these transformations in silver layer, and then we'll generate these new columns in gold layer. So let's open the notebook for our silver layer. So here I created a data frame from the bronze table. And if you look at the schema, everything is string. Okay. So now for transformations, we will convert 2 to 2. See, so we are doing for quantity, when quantity is 2, convert that to number 2. Otherwise, cast it to integer. Okay. So overall, you will get entire column as integer. Second thing you want to do is in the unit price, there is this dollar symbol. So you will say df dot with column. So you always use this with column function whenever you want to do transformation on a specific column. So on unit price column, what kind of transformation I want to do? I want to replace this dollar symbol with space. And this is a regular expression, by the way. This is the format for regular expression. And then cast it to double. The third thing I want to do is from my percentage column, right? Like I have this discount. I want to remove this percentage and I want to convert it to a number, right? So this will be double. Then you want to do some processing with coupon code. You want to convert that to lower. So what is my coupon code? Well, coupon code is this. So I want to convert from capital to lower. This all depends on the business requirement. Okay, it may vary. What kind of transformation you want to do may vary based on the situation. Then you want to change web to website, app to mobile, right? We discussed that. Okay, so let's run all of these transformations. So when I display the rows, you will see some of these things getting in effect. Okay, so see discount percentage, that percentage thing is gone, and text amount, this web is website, mobile is mobile app, and this is in a lowercase. We also got these two metadata columns. Okay, so the next thing we will do is conversion of date, because this DT column is string. You want to convert it to a date format. So when you say to date, it will actually change the data type and it will still keep it in YYYMMDD, right? YYYMMDD. See, right now it's ABC string. This will convert it to date format. Second thing you want to do is for order timestamp, you want to convert that to a timestamp, because see, right now everything is string. We just saw, right? See, order timestamp, everything is a string. So you want to convert it into proper timestamp. Then the item sequence, you want to convert that to integer. Text amount, you want to remove some invalid characters from the text amount, just in case if there are any characters, there might be leading and lagging spaces. You want to then convert it to double. And then you are adding the process time. So this will add a current timestamp at which that particular record was created. Okay. So let's execute this code and then let's display this. All right. So now when you look at DT, see, this data type is date. Previously it was here, it was string. Okay. This data type is timestamp. Previously it was string. Then item sequence is integer. All right. So you can do some quick check. And if you look at print schema, you have the right data types. Okay. At the end, as always, you write it to a silver delta table. So see, now in silver schema, I got order items. And here you can quickly spot check. You can do some quick quality checks here. And you will find that now this silver table is in a good shape. And the third step in our Medallion architecture is processing a gold layer. Okay. And in the gold layer, we are going to create a bunch of new columns. Okay. So this is the table that we have. The first thing we'll do is create gross amount. Gross amount is simple, folks. Very simple business logic. Quantity into unit. Let's say you go to a store, you bought, let's say you went to a store and you bought 2 cans of beans. Okay. So 1 can of bean is $5. So 2 cans of bean is $10, right? So that will be your gross amount. So quantity into unit price. And then discount amount is gross amount into discount amount divided by this. Okay, so that's your discount amount column. Sales amount column is simple, gross minus discount plus tax. Yeah, you have to pay tax too. Okay, don't forget government. And date ID is just a unique identifier for your date. And then you also have this coupon flag, whether you have coupon code or not. Okay, so if you have coupon code, then flag will be 1. No coupon code, it will be 0. So let's execute this and look at this. Now you have at the end, you have this gross amount. See, gross amount, discount amount, sales amount. These are the new columns, date ID and coupon flag. Now we will also normalize the currency, because see, these transactions are in different currencies. And when you are doing holistic review of your business, you may want to bring everything into single currency. Let's say our executive lives in India and they want to see everything in INR currency. So you have to convert all these numbers into common INR currency. And for that, you have provided the spot rates, currency conversion rates. So for USD, for example, is 88.29. So right now we are hard coding, but if you're working on the real project, you will use some currency APIs. See, if you Google currency APIs, you will find a bunch of APIs. So you can maybe buy a subscription to this, and by using HTTP call, by using that API, you can get the real rates as of that particular transaction date. Okay. So let's initialize this data frame. So rates DF is just a data frame with 2 columns, currency and the conversion rate. And then you are going to do a join. You have your main data frame. You will join based on that currency. Okay. So let's do a join. And after doing join, what you get is in your orders fact table. See, this is my orders fact table. Towards the end, you will get conversion rate, right? Like the conversion rate and the sales amount in INR. Okay. All right. So if you look at this code, you will get an idea. Then you want to create the data frame for your final gold table. So you will select bunch of columns. You are renaming some columns. Instead of DT, you are saying transaction date. Order TS, you are saying transaction TS. So this way, when data analysts are using this goal table for their BI needs, or let's say when AI engineers or data scientists are using this for their AI needs, these columns are more descriptive. All right. So once you do that, you are going to display this. And here you see this nicely processed table, which you will write to your goal table. Okay. And let's do a quick spot check. So go to gold, and in gold, you will see fact table, order items, and look at this. My gold data, my gold is ready for my BI. See here, you're finding, you can do some again spot check. We have this net amount INR, all of this, and it's now ready for our BI. And just a quick sanity check. I just want to make a count and see my number of records are 183,000. Before we start building our BI dashboard, I want to highlight this amazing AI feature called Genie. Now AI is integrated throughout this product, and you already see this kind of suggestions at the top of these tables. So let's say for the fact order item table, I want to know how many transactions used coupons each month. So when you click on it, it will actually generate a SQL query. See, it generated a SQL query. You can review it and then you can run the query. Isn't this amazing? So in August, September, October, these are the transactions which used coupon. Now let me go to Genie. See, this feature that I just showed you is integrated into catalog section, but you can go click on Genie and click on new. And here you can go to e-commerce. Always use gold for your analytics purpose, right? Because bronze is raw, silver may not have BI ready columns, etc. So in the gold, let's select or for tables, hit create button, and then give some name to this, right? So this is e-commerce Genie space. And on the right hand side, you are seeing these tables. You can also give instructions to LLM. Let's say if you want answer to be generated in a specific format, here is where you will do your prompt engineering. And then there are settings like what kind of warehouse you want to use, space ID, and so on. So let's close this. And let's start asking these questions. So the first question I have is how many transactions were made in US currency? And by the way, I'm going to give you this text file with some sample questions. Okay, so I'm just using the questions from that file. So see, total number of transactions in USD are these. And if you want to verify your code, see, it will generate SQL query, right? So select count distinct transactions IDs from this gold table where the currency is USD and transaction ID is not null. See, it's so detailed. Then the second question I have is, what is the total revenue in INR and number of order lines by month? And show me the monthly trend chart. So see, I got the number of orders per month, August, September, October, and the revenues in each of these months. And I got this chart, right? So one is total revenue and order line count. Now you can click on this button and you can modify your visualization. So let's say I want bar chart instead of line chart. Okay, so then you get this. You can add labels and so on. So you can customize your chart here. And the next question I have is, what is the average revenue per region? Remember, we created region column like East, West, and so on. And look at this. In the England, there are these regions. So it is showing you that. Then in India, these are North, East, etc. You can also modify your question and you can say, what is the average revenue per region? Show it in table along with country. So see, country was missing initially. Now you have region as well as you have country. And once again, you can verify your SQL query here by clicking on show code. I personally love this Genie feature. It's making your life so easy. As a business user also, you can just type in your question and get your answers. Okay, so we are going to attach this txt file, which has a bunch of questions, and you can also come up with your own questions. Now, before we create the BI dashboard, let's analyze our needs. See, we want to do some visualization such as, okay, what is my net sales per quarter? Now, when you look at our gold fact order items table, it has net amount, okay, net sales amount. and it has date, but it doesn't have quarter data. So naturally we are going to do a join based on this data ID. So let's say this is a data ID. We will have same data ID here in dim date table, and this one has this quarter data, Q3, Q4, and so on. So doing join between these tables is one option, but in the industry, we have seen this practice where people join all these tables and they create one flat table, one highly denormalized table, which has all the columns. So what we will do here is create a view. Instead of table, we will create a view which will join all these tables, and we get one view where we have all the columns. So for this, I will click on SQL editor. So I'm in the SQL editor here, and I will create a view here. So you will say create or replace view, and this is my view. Okay, and this view here, you will write a query that is joining all those tables. So let's see how that query looks like. So essentially, you are selecting data from your main goal table, which is your fact table. You're joining it with dim date on data ID. Then you're joining it with products on product ID. And then you're having all this bunch of columns. Okay, so let me just run this and show you the result. So it says okay. Now I can go to catalog, and in gold, see, I am seeing a view. So when you click on this view, now I have this highly denormalized view or table where I have everything. So let's say you have a transaction, right? This transaction, okay, which region it belongs to, which category it belongs to, then hour of the day, see, rating count, quarter, right? I don't think we have region here because we did not do a join with the customers table, but that's okay. At least we did a join with our date calendar table. So see, we have quarterly data. What are my revenues on weekend versus weekdays? So we have all that information here. Now we of course did a join with order items and products, but you will see this practice where they even do join with customers. Let's say they join every single table and they create this one huge table with so many columns. And now your data analyst, when they're building a dashboard, all they have to do is refer to that table. Let's now create a dashboard. You will click on dashboard in the left hand side menu option. Click on create dashboard, and let's hide this. So see, here you will see different options. So the first option at the top is pages. So you can create different pages in your dashboard. So let's say you have a view for sales, you have another view for marketing, third view for supply chain. Based on different business functions, you can have different views. I will close this because this is for filters. We'll look into it later. And here we will begin adding a text box. So add a text box here, and we will call this sales insights, right? Sales insights for your e-commerce business. And let's select heading 3. Okay, or let's say heading 2. And you can resize it. Then you can click here and add a visual here. Now you need to connect this with a data source. Here I don't see any data set. So let's go to data and add a data source. So go to e-commerce, gold, and the view that we created. Okay, so let's confirm it. So it connected with it and you are seeing the data, which means my dashboard is connected with my data source. So now when you click it, here you can select that particular view in your data set. The moment you do that, here AI assistant will give you some suggestion, okay, what kind of dashboard you might want to have. So let's say you want monthly sales trend, okay, you want to know monthly sales trend, and see, it will create this nice visual for you. So here I see in August I got 621 million of sales. In September I got 571. In October I got 618 millions of sales. Okay, you can just say accept. You can change things, by the way. So see here what it did is for this particular visualization, let me create this visualization manually so you get an idea. So I will create the same thing. So here you will select line chart. Okay, on x-axis you will have month name. Okay, so month name is on x-axis, and on the y-axis you will have net sales amount, right? Like net amount, let's say net amount, and that too a sum of it. Now it's the same data, but here the order is not correct. August, October, and then September, right? So August 621, so August 621, right? October 618, 618. Okay, so in the AI generated suggestion, the order was correct because they use this monthly transaction date. Okay, so let me just show you monthly transaction date. So here transaction date and then monthly, right? So you can say monthly, yearly, whatever, and you can give it some title. So title is yes, so monthly sales trend. You can change this label. So on the y-axis, how do I change label? So by the way, when you click this label, it will show you this annotation, right? This is useful, right? See all these numbers. And let me go ahead and delete this. So here, let's say I want to change this particular x and y-axis label. So here the display name is sum of net amount. So you can just say net amount, and then on the x-axis display name is month, let's say. Okay, you can then go ahead and create another visual. So let me add another visual here, and let's say you want to know net amount by category, see, or net, let's do net amount by category. So you see you have all these categories. So let's accept this suggestion, and this particular category has 1.38 billion cells, right? Electronics is a highest selling category, then home and kitchen is this much. You know, you can change the visualization type. If from bar chart you want to change it to something else, you can easily do it so using this drop down. Then let me add a heat map actually. So here I'm going to add a heat map. So let me just make this really big, and I will select a heat map here, and x-axis is hour of the day. So hour of the day, and y-axis is net amount, right? Sum of net amount. So here let's select this. So this will be, actually net amount will be in the color. So the y-axis will be day name. Okay, so let's call day name in the y-axis, and then in the color you can have net amount. So now see, what you are seeing here is you have all these days, right? And the regions which are darker has more sales. So you can say that, first of all, Saturday, Sunday, I have good sales. See, you have more darker blocks in Saturday and Sunday. And Saturday on this hour, right, at 2 o'clock, or let's say at 5 o'clock, I have more sales. Okay. So you can do this kind of heat map analysis as well. You can also click on filter and add the filters here. So let's say you want only particular category. Okay, so you will say category name here, and see it will show you different categories. So let's say you want to do analysis only and only for electronics. So when you select electronics here, see now data is refreshed to only electronics. I mean, in this bar you will obviously see only one bar chart, but these numbers, this sales number, this particular thing is very useful, are only for electronics. Then let's say for books, you want to analyze the sales number. So see, now it is refreshing. For books, the sales are less. But see, using this particular option, you can add all kind of filters. All right, folks, so that's it for the dashboard. As I said before, you can create another page, let's say for marketing, just in case if you're marketing data. And this kind of dashboards can be used by business users to get the insights on the overall status of your business. In the end, let's quickly talk about orchestration. See, in our project, whatever we did is a historical backfill. When you start working on a data engineering project, you might have some historical data. So we had this last 3 months of data, which we backfilled by running those notebooks manually. But the second phase, once your data engineering infrastructure is set up, is daily incremental updates. Now, we did not cover this in this project, but usually what happens is, now let's say sales transactions are happening on a day-to-day basis. Those transactions will keep on coming. Remember our order items table? So that table will have new and new CSV files coming in every day. And we need to set up some automated processing. So whenever new data comes in, it will go through this entire pipeline all the way till your dashboard. And for that, you will use the feature of these job runs. Okay. So the way you will do it is, you go to job runs, you create a job, and here you will run your notebook. Now, once again, folks, this, whatever I'm showing you right now, is valid for daily incremental update. What we did in this project so far is historical backfill. So we have notebooks only for historical backfill. Okay. So let's assume that we have done coding for daily incremental update and we have those notebooks. Let's assume that, okay. We did not do it, but we are assuming it. In that case, you will create this different task. So let's say this particular task is of type notebook. Then the source is going to be workspace and the path is going to be in project e-commerce. Let's say you have DIM processing, right? Dimension processing for bronze. And this is the notebook. 1_dim_bronze is a notebook that will do dimension data processing for bronze layer. Okay. You will select your compute. You will add any parameters that you want to add, and then you will say create a task. Okay. And this task will be, let's say, dimension bronze processing. Okay. And create a task. So when you do that, see in your diagram here, let me just make the whole thing like smaller. So now you got this. Then you can say add a new task of type notebook here. So after this step, you will do what? Well, you will do silver processing, right? So you will say select silver, and the name here is dim silver processing. Create a task, then you add another task, which is again a notebook, and it is dim gold processing. And here this is dependent on this. See, this task depends on this. You can have branching logic as well. And here you select dim gold and you will say create task. Okay. So now this whole thing is the processing for your dimension data. Okay. And this job will be called dimension processing, right? And then similarly, you will create another job for your fact processing. And then you can have a parent job which will run both of these. And then you can set a trigger. So see, in the schedules and trigger, you can say add trigger, and you can say schedule or on file arrow. Let's say you are saying schedule every day. Let's say you want to run it. You want to run it every day at, for example, 11 p.m. in the night. Once all my business transactions are done, 11 or 12 o'clock, whatever, right? And you can show the cron syntax as well. Active and say save. So now what will happen is this pipeline will run at 11 o'clock every day. So what people do is, even when I was working at Bloomberg, we'll have stock market data and stock market will close at 4 o'clock. All the data stops coming. Then after some buffer, let's say 5 or 6 o'clock, you will run this kind of pipeline every day. So right now we have set up a schedule every day at 11 o'clock. This pipeline will run. It will do processing for bronze, silver, and gold. Okay. Ideally, what you do is, this is the pipeline for dimension processing. You will create another pipeline for fact processing, and you will have a parent job which will process both dimension and fact. And you will do scheduling on that. You will not do scheduling on this one. Okay. But I just want to just show you this quickly. And this is something valid for daily processing. For historical, we run it one time.
And that's it. Okay, so this is how things work in the industry. Big companies which are having this data engineering infrastructure, they will have this kind of pipelines set up, and these pipelines will automatically run. You can even run it right now. See, this is a manual way of running it. Otherwise, you can run it on a trigger.
So Peter, what have you found?
So Tony, here is my quick report. I'm sharing it here on my screen, and I would like to mention my findings. So the first one is, it is scalable, it is easy to upgrade or downgrade capacities, and it is fully managed. That means you don't have to worry about infrastructure. You can just focus on your business logic. Second point was about adoption. So on that, I spent about 2 weeks and I was able to get this project done. And the adoption won't be difficult for our team. That's what I can say from my experience. The third thing, it was about unification. So for that, it provides almost everything in one place, and of late, they are doing a lot to bring these new features to make it all in one place. And I really like some of the features like workflow, dashboards, Genie, and there is a lot more, as I stated in the report.
Okay. So Peter, to me, this looks positive, and I have, during this time, I kind of tested it myself too. So I'm quite positive. Let's give it to Bruce and wait for his decision.
Hope you enjoyed learning from this mini course. If you want to get certified from Code Basics on this mini course, then you can visit our website using the link provided in the video description. You can take the exam there and get certified. Also, if you want to showcase your work, then feel free to post it on LinkedIn, tag Databricks, Code Basics, myself, and Hemanand. I wish you all the best and thank you very much for watching.